Now we'll move on to the next chapter. The next chapter is declaring PL/SQL variables. Use of variables. Variables can be used for temporary storage of data, manipulation of stored values, and it is reusable. So example, declare within the declare section, we declare the variable v underscore fname varchar 200. Varchar 2 is a data type, character data type, and the length of the data type we are specifying is 100. And v department number is equal to is a number. Then in the begin section, begin and end, we write select first name department ID into VF name, V department number from maybe employees. So the first name, as for example Jennifer, is assigned to VF name, and department number 10 is assigned to V department number. Requirements for variable. A variable must start with a letter, can include letters or numbers, can include special characters such as dollar, underscore, and hash, must contain no more than 30 characters, must not include reserved words. Starting with Oracle Database 12c Release 2, the maximum length of identifier name for most data type object can increase to 128 bytes. So 128 character is the length now. Earlier it was restricted to 35. Handling variables in PL/SQL. Variables are declared and initialized in the declarative section, that is between the declare and begin. Used and assigned new values in the executable section between begin and end. Passed as parameters to PL/SQL subprograms like procedural and functions. Used to hold the output of a PL/SQL program. Like get temp salary is a function which return a value, so we are calling get temp salary with the parameter 100, and it returns a value maybe 2, 3, 4, 2000, 3000, 4000, whatever it is, and that is stored into v underscore salary, which is a variable. So declaring and initializing PL/SQL variable examples. If you look at examples, v hire date is declared as a date. V department number is declared as a number 2. 2 is a precision for the number, and it is not null, so we are giving a default value. V location bracket 213, and we are giving a default value of Atlanta. C underscore com, this is a constant, units of type number 1400. The difference with the constant is you cannot change the value of constant. So C underscore com, you cannot change the value for this variable in the executable section. But other variables you can change the values. They are mutable. There are some guidelines for declaring and initializing PL/SQL variables. First of all is follow naming convention. Use meaningful identifiers for variable. Initialize variables designated as not null and constant. Initialize variable with assignment operator : equal to or the default keyword. The examples are here. First one is using : equal to. The second one is using the word default. Declare one identifier per line for better readability and code maintenance. Avoid using column names as identifier. Like employee ID, employee underscore ID is a column name in the employees table. So avoid using that as a identifier. Like employee ID, employee underscore ID number 6. This is not a good practice. So avoid using column names as identifiers. Use null constraint when variable must hold a value. When the variable must hold a value, use not null. If your string contains apostrophe identical to a single quotation mark, you must double the quotation mark. Like within a quote, if you are writing another quote, you have to escape it with a quote. Like if you want to write Father's Day, you should write Father's two single quote S day. The first quotation mark acts as an escape character. This makes the string complicated, especially if you have SQL statements as string. You can specify any character that is not present in the character string as delimiter. The slide shows how to use Q notation to specify the delimiter. So the example is uses exclamation mark as delimiter. Consider the following example. You can start the string Q if you want to use a delimiter. So if you want to use a delimiter, you can start Q, then exclamation mark, which specifies the delimiter. The following example is how to use a delimiter bracket as a delimiter. So here see Q, then within quote, single quote, it's opening the third bracket, Mother's Day, closing the third bracket. So you can use the Q notation effectively if you want to avoid using two single quotes. But for simplicity, you can use two single quotes to escape the quote within a quote. So this is about delimiters in string literals. Types of variables. PL/SQL variables are of scalar, composite, reference, large objects, and non-PL/SQL variables like bind variables. Scalar data type, they hold a single value, have no internal components. We can arrange it in 4 categories like character, date, number, boolean. This is a table where the range is specified. So we normally use char. This is up to 32,767 bytes. So we normally use char, varchar 2, number, and date. These are the commonly used variables, but you can refer to this chart for details about other data types. All the data types are mentioned here. LOB data types are like photos, movies. They are stored in blob, column, column. Blob is for character large object. Blob is for binary large object. Defile is a binary file. The source of this is a file, and the enclave is national character large object. So that's dependent on character set. But commonly we use blob, and bfile. Blob is to store large character objects. Like if you have a very big, suppose you have very big character, very big string, like say, which exceeds 4,000 bytes, then you can store it in blob. Blob is used to store uh, images, binary objects, PDF files. These are stored in blob. B file is similar to blob, only thing is that file it refers to a file which is stored in the file system. Person type attribute is used to declare variable according to a database column definition or another declared variable. Like emp underscore l name is employees dot last name person type. That is the last name column of the employees table person type. So if the last name is varchar 30, then l name will also become varchar 30. The next example is we are declaring balance as number 72, and then we are telling min underscore balance is declaring it as balance percent type. That means it is also number 72, and then we are assigning 1000 to it. Advantages of percent type is you can avoid errors caused by data type mismatch or wrong precision. You can avoid hard coding the data type of variable. If you need to change the variable declaration in a column definition changes, you don't need to change the variable declaration. If the column say last underscore name, it was set varchar to 40, now it is reduced to varchar to 30. So you do not change your program. It will automatically become varchar to 30 when the program executes, because it is percentile, not hard coded. Bind variables are created in the environment, also called host variables, created with the variable keyword used in SQL and PL/SQL block, accessed even after PL/SQL block is executed, referenced within with a preceding colon. So like here example, variable b underscore result is number. So this is a bind variable, and we are storing select sal into 12 plus LVL commission percent comma 0 into colon b result. So next, when this PL/SQL block is completed execution, we can print the number of b underscore result. So it is per session. The bind variables as 4, and we can print the bind variables. Okay. Okay, now let's go back to writing some code. So here we are declaring vdate as date, vnumber as number, and vname as varchar to 100. So we are declaring these three variables, and then we are printing these three variables. Then we are manipulating v number is equal to v number plus 10. We are increasing the value of v number by 10. Value 10. And we are changing it from Khaled to Carla. Then we are printing the vname. Then vdate, we are assigning a value to vdate, and then we are printing the vdate and vnumber. Let's execute this. So this is the result of the execution. The next one is vdate. We are assigning to sysdate. Sysdate When you write this way, it takes the system date, whatever is today's date. B number 10 into 20, 10 into 2, that means it's 20, and then we are declaring a constant 3.14. Then we are printing these numbers, then we date, we are telling to add 10 days to be date. So let's execute this. So today is 23rd August, then 10 into 20, 3.14, and then 10 days from now is 2nd September 2019. Okay. The first one just prints welcome. Just prints welcome. The second one, Father's Day. See how we have escaped the single quotation with another quotation mark. Because within a quote, if you write quote, it will give error. Suppose if we write something like this, so it will give error. Quoted string not. Because within a quote, you cannot write a quote. So you have to escape. So when you escape it, it will print Father's Day. It will print the quotation mark. These are the examples of Q notation. We will execute this. In both the cases, the quotation mark is correctly printed. So this is the Q notation, and this is the normal escaping of the quotation mark. These are some other types of variables: number, date, timestamp, and interval, year to month. So we are assigning 125.323 to number. Initially it was assigned 300, now we are changing it to this value. Then vdate is assigned sysdate, and timestamp is assigned current timestamp. V period is assigned 03-04. Let's run this. So this is the outcome. As you can see, this one is the value of the number variable, this is the date variable, this is the timestamp, this is the interval, and this is in the timestamp variable. This date, this is sysdate, and here we are using some qchar function on sysdate, and the format is ddmmyyyhhmiss. So that's why it's printing as hhmiss. Here we are assigning employee number to number 10, rename to Khalid, salary is salary person type, hire period, interval year to month, and name number 1 is VM number percentile. VM number is number, so this is also number. Remember, when you do a percentile, it won't get initialized. So only VM number is 10, but VM number 1 is not as initialized to 10. So we are printing M number, E name, then we are setting salary to 5,000, printing the salary. We have period, we are assigning 1 to 3, 1-3. We are printing the high period, and then finally the M number 1 we are printing. So let's see. Yeah, M number 1 is null because it is not assigned any value. So M number 1 is null. The salary is printed at 5,000, name is Khalid, M number is 10. Write a PSQL block, first name, last name of for employee 100. So this is, remember when we do employee 100, employee is equal to 100, it should return only one row. If it returns more than one row, it will result in an exception. We'll cover that later. So let's run this. So Stephen King. So employee ID 100 is his first name and last name. First name is Stephen and last name is King. Suppose we say employee ID 9000. If we run this, it will give an exception. No data found because there is no employee in the employees table with employee ID as 9000. So it results in no data found exception. We'll come to the exceptions later, but this is just to show you that the select statement within a PL/SQL block must select into, when you are selecting into some variable, it must return a single record. Otherwise, it will give it. If it doesn't return any record, then also it will give an exception. If it returns more than one record, then also it will give an exception. If it doesn't return anything, it will give no data found exception. If it returns more than one record, then it will give exact fetch returns more than one record. This is an example of bind variables. Let me execute this. No, this has to be executed from SQL place. No, it cannot be executed here. There, in SQL plus, you can, in a SQL plus session, you can declare a bind variable, then assign some value in the bind variable through PL SQL code. And then after the code is executed, as you can see, PL SQL procedure successfully completed. We are printing the value in V underscore sal, which is 24,000. There are some more examples of bind variable. If you set auto print on, it will print automatically. It is automatically printed, no need to give the print step because we have said auto print on. So that is about variables. The next one is writing executable statements. We'll take a short break, 5 minutes break, and we'll resume after 5 minutes. Good morning. Today's session is about PL SQL, Oracle PL SQL. So I'll give you a overview of what are the topics that we are going to cover in this session. So the first one is overview of PL SQL. Next one, declaring PL SQL variables, writing executable statements, interacting with Oracle DB server, writing control structure, working with composite data type, using explicit cursors, handling exceptions, creating procedure, creating function, creating packages, working with packages, using Oracle supplied packages in application development, using dynamic SQL, design consideration for PL SQL, creating triggers, creating compound DDL and event triggers, using PL SQL compiler, managing PL SQL code, and managing dependencies. These are the 20 topics that we will cover in this course. So let's start with the first chapter, overview of PL SQL. So overview of PL SQL. PL SQL basically is a procedural extension to SQL. SQL is structured query language. It is used by all our DBMS to query the data stored in the database. Database means tables and columns and rows. So data is stored in rows and columns in a table. So these tables are internally related. That's why it's called Relational Database Management System, and Oracle is one of the Relational Database Management System, RDBMS. And to query RDBMS, we need the interface to query an RDBMS is SQL, Structured Query Language. So Oracle also has a flavor of SQL. And PL SQL is a procedural extension to SQL. What that means is basically you can write your if then else logic on top of SQL queries. So that is PL SQL. Data manipulation and query statements of SQL are included within the procedural units of code. It's a procedural unit of code where basically data manipulation like insert, update, delete, and select queries and select statements. This can be written inside the procedural unit of code, and that is what is PL SQL all about. Why to use PL SQL? Basically, PL SQL As for example, if you are updating the salary of department 20, 30 and 40, if you have to write it in SQL, you have to write multiple update statements. Four update statements you will have to write, individual update statements. As you can see, updating PMP says salary is equal to salary plus 100 where department ID is equal to 10. The first use case where we raise the salary by $100. Similarly, we'll have to write 4 different update statements. Whereas in PL SQL, we'll write a procedure update salary, which will take the parameter department ID and the amount by which the salary has to be increased. And then within begin end, we will write the one single update statement. So this is the difference between SQL and PL SQL. In PL SQL, we have a procedural unit where we can write our logic using the same SQL statements. PL SQL provides a block structure for executable units of code. Maintenance of code is made easier with such well-defined structure. So PL SQL provides a block structure. I'll come to what is a PL SQL block in the next lecture. PL SQL provides procedural constructs such as variable, constants, data type, control structures such as conditional statements and loops, reusable program units that are written once and executed many times. So these are the features of the language. So PL SQL environment. We have PL SQL block which contains the procedural statements and the SQL statement. The procedural statements are executed by procedural statement executed within the Oracle database. Sorry. And the SQL and the SQL blocks are executed by the SQL statement executed. So with the help of both procedural statement executor and SQL statement executor, the PL SQL program is executed. Benefits of PL SQL: integration of procedural construct with SQL, improved performance, modularized program development. You can create procedural function packages, integration with Oracle tools like Oracle Forms, Oracle Reports, and Oracle Apex. Portability: PL SQL programs can run anywhere where an Oracle server is running. So it can only run on Oracle server because PL SQL is a product of Oracle and it is designed to run on any Oracle server. And also it has exception handling capability. So PL SQL block structure. PL SQL block structure is shown here. It starts with declare, which is an optional part of the block. And here variable cursor, user defined exceptions, these are defined, these are declared. Then we have begin, which is the mandatory part. In the begin, we write the SQL statement, PL SQL statements. Then we have exception, which is again an optional part. This is where we write actions to perform when some error occurs. And then finally end, which is mandatory. So begin and end are mandatory, declare and exception are optional. Block types, we have anonymous block types, which starts with declare, begin, exception, end. Then we have procedure, which is a stored subprogram, and function, which is also a stored subprogram. Procedural functions are like written once and executed many times, but anonymous blocks are executed once. They don't have a name, so you cannot call an anonymous block. You cannot store an anonymous block. That's why it's not a subprogram. That procedural function, they are subprograms. Difference between anonymous blocks and subprograms. Anonymous blocks are unnamed PL/SQL blocks. They don't have a name. Subprograms do have a name. They are named PL/SQL blocks. Anonymous programs are compiled every time. Every time you run anonymous block, it is compiled. But subprograms are compiled only once. Anonymous blocks are not stored in the database. Subprograms are stored in the database. Anonymous blocks cannot be invoked by other applications. Subprograms are named and therefore they can be invoked by other applications. Anonymous blocks do not return any value. Subprograms called functions must return a value. So function must return a value. Anonymous blocks cannot take parameters, but subprograms can take parameters. Okay, now let's write some, depending upon what we learned till now, let's write some code here. So the DBMS output line is like messaging for PL/SQL. So any message you want to print on the screen, on the console, you write DBMS output line. DBMS output is a package, Oracle supplied package, and put line is a procedure under that package. We'll come to package and procedure later. But remember that this DBMS output line is a way to do messaging in PL/SQL. Right? In other languages, you might have like message or alert or prompt. Similarly, for PL/SQL, the interface is DBMS output line. So let's run this. So this is the output. This is my first anonymous block. So this is what my first anonymous block. So my first anonymous block. Okay. Let's run this. This is the first line. This is the second line. So whatever I am trying to print, it gets printed. And here you see the mandatory. As I said, that anonymous block is a mandatory part of begin and end. So within begin and end, you can write PL/SQL code. Here we have a declare or section also, begin and end. If we run this, hello world. Next here we declare a number. In begin, we assign 5 to the number, and then we have 2 DBMS output. One is hello world, one is the number itself. So if I run this, hello world 5. Okay. This you have already seen. Okay, right. Now we'll move on to the next chapter. The next chapter is declaring PL/SQL variables. Hi, I am back. So we'll continue with writing executable statements. Executable statements are Identifiers inside PLSQL block. Identifiers are names given to PLSQL objects. For example, VM name, VM number, PE name, first name. Not recommended. This way it is not recommended to use space in the identifier names. Delimiter are symbols that have special meaning like colon, plus, star. Literals, any value that is assigned to a variable is a literal. Like B name is equal to khale, colon equal to khale, VM number is equal to 10, B flag is equal to true. B flag is equal to true is a boolean variable. So these are literals and comments. This is a single, you can give a single row comment by hyphen hyphen or within a slash star and ending with star slash, you can give a multi-line comments. Delimiters are simple or compound symbols that have special meaning in PLC. Simple symbols, they have special meaning. Plus is addition operator, minus is subtraction or negation operator, star is multiplication operator, forward slash is division operator, equal to is equality operator, and at is a remote access indicator, semicolon is a statement terminator. Compound symbol is, the first one is inequality operator, second one is also inequality operator, the third one is concatenation operator, the next one is single line comment indicator, the next one is the beginning of comment delimiter, ending of comment delimiter, and the last one is assignment operator. So commenting the code, you see this compute annual salary based on monthly salary input from the user. This is a multi-line comment. Then the following line displays the annual salary. This is a single line comment. This is how you give comment in PLC. This is single line comment or a multi-line comment. SQL functions in PLSQL available in procedural statement. Single row function, function which returns a single row. Not available in procedural statements and decode. You can use it as SQL statement inside PLSQL but not in PLSQL construct. So improve functions and decode you cannot use in procedural statements. In starting 11G, you can start with next val in a procedural statement like view new ID colon equal to my sequence dot next val, but before 11G you have to write it in a SQL statement. You cannot write it in procedural statement. Data type conversion converts data to comparable data types. These are two types, implicit conversion and explicit conversion. The functions used to convert the data types are toCat, toDate, toNumber, toTimestamp. toCat will convert a number to a character, toDate will convert a string to a date, toNumber will convert a string to a number, and toTimestamp will convert a string to timestamp. So you can have a PLSQL block inside a PLSQL block. An executable section that is begin end can contain nested block. An exception section can contain nested block. So within a begin end, we can have another declare begin end that is a nested block. Nested block example. So here we have an outer block and then we have an inner block. So we are printing the inner variable as well as we are printing the outer variable. So this is how a nested block will look like. Programming guidelines make code maintenance easier by documenting code with comments. developing a case convention for the code, developing naming conventions for identifier and other objects, enhancing the readability by proper indenting. SQL statements, normally case convention is uppercase. There is an example, select inside. PL/SQL keywords are in uppercase like begin, declare, begin, if, end. Data types are in uppercase, varchar to boolean. Identifier or parameters are in lowercase, like p underscore sal, emp underscore cursor, g underscore sal, p underscore inf number. Database tables and column names, this should be in lowercase. So these are just programming guidelines. It is good if you follow them, but you don't keep any error if you don't follow them. Indenting code, like for clarity, we need to indent each level of code. Here is an example, declare, begin, end, and proper indentation with the select statement and the variable declaration. So that's it about it. Let's look at some code sample. So the first line is a single line comment. So this is a single line comment. This is how you give a single line comment. And this is how you give a multi-line comment. So this is a single line comment. So we are declaring first name, last name, salary, hire date. Though the hire date this way is not recommended, but you can still use it. So from employees where employee is equal to 100, we are selecting the first name, last name, salary, hire date into these variables, and then we are printing the variables. We are printing those variables. Let's execute this. So first name is Steven, last name is King, salary 24,000, hire date 7 June 2003, employee first name length is 6, 3 letters of the first name is Steven. 3 letters of the first name, we are using the substring function. Substring function returns the starting position and the length of the string. Then length we are using to find the first name length. Here we are doing some date arithmetic like vdate plus 8, 8 days, vdate minus 8, 3 days prior to vdate is 6 days. Then we are converting vdate to this format, character format, to char function. We are adding 2 months to vdate, and we are formatting the salary by thousands separated and dollars. So let's execute this. Let's see the output. So this is the output. So sysdate, vdate, sysdate is 23rd August 2019. Vdate plus 8, it is 31st August, 8 days forward. Vdate minus 3 is 3 days backwards, so that is 20 August. And vdate in DD, MM, YY, HS, MISS, AM, PM format. This is the format. This is the format. Add months, 2 months, 2 months we will do August, September, October. So that becomes October. And this is the took care of the salary. So we are declaring a global variable in the sense in the declare section, then an inner block. This is a nested block within the outer block. And outside the nested block, you cannot access the vlocal variable, but this global variable is accessible in the inner block. This is a global variable, this is a local variable, this is a global variable. Now if we want to run this, it will give an error. VLocal must be declared. It cannot find the VLocal variable. Then father name Khalid, birthday is 20 July 1981. Then we are putting father name, birthday, child name, child's birthday. Child name, child's birthday is in the inner block. And father name, father's birthday is in the outer block. So we can still access it in the inner block. So let's run this. So you get the father name, father birthday, child name, child birthday. You can also specify a name to the outer block. So here also there is an inner block, same as the earlier code, that you can specify a name to the block also. So it's the same output as the previous one. So that's it about this chapter. Chapter 4, yeah, that's it. Interacting with Oracle DB Server, the next chapter. It's chapter 4, yeah, that's it. Interacting with Oracle DB Server, the next chapter. SQL statement in SQL used to retrieve a row from the database using select command. Make changes to the row data to the rows in the database using DML command. Control a transaction with commit, rollback, or setpoint command. PL/SQL does not support data definition language (DDL). That is, create, drop, alter. These are not supported. PL/SQL does not directly support data control language like grant, revoke. You have to use dynamic SQL to execute DDL and DCL commands. Dynamic SQL will cover later. Select statement in PL/SQL clause. The into clause is required. Queries must return only one row. Earlier also I said that when you do a select into, the query must return a one. Select statement within PL/SQL. If the query returns no record, it will give no data found. If it returns more than one row, it gives the error too many rows. So we have to be sure that it returns one row. So if you write a statement like select hire date, sys date into hire date, sys date from employee, that employee ID is equal to employee ID, where we have an employee ID 176 assigned, but this will not work because employee ID is the name of the database column. So when you do employee ID is equal to employee ID, it will take the database column name will take precedence. So it is writing It is like writing 1 is equal to 1, so it is always true. So it will return all the employees. And if it returns all the employees, it will give the error exact fetch return more than requested number of rows. So data manipulation in insert, update, delete, merge, we can do all this in PL SQL using DML commands. SQL cursor is a pointer to the private memory area allocated by Oracle server. A cursor is used to handle the result set of a select statement. There are two types of cursors. Implicit cursor, which is created and managed internally by Oracle server to process SQL statement. Whenever you write a SQL statement, an implicit cursor is opened and closed. An explicit cursor is something which is declared explicitly by the program. SQL cursor, that you have already learned that you can include SQL statement that return a single row in PL/SQL block. The data retrieved by SQL statement should be held in variable using into flow. The SQL server allocates a private memory called the context area for processing SQL statement. The SQL statement is parsed and processed in this area. Information required for processing and information retrieved after processing are all stored in this area. You have no control over this area because it is internally managed by Oracle server. A cursor is a pointer to the context area. However, the cursor is an implicit cursor is automatically managed by Oracle server. When the executable block issues a selection, PL/SQL creates an implicit cursor. So implicit cursor, you don't have to do anything. It is Oracle internal that it creates an implicit cursor to the context area. SQL cursor attribute, but you can use the SQL cursor attributes for implicit cursor like SQL %found, SQL not found, SQL go found. So that's it about it. Let's run this. Let's see some examples. So here having is the reserved word. You cannot have having as a variable name. If you do that, it will give you an error. You can declare a variable in the name of a function, but you should not do that. You should not do that. That is not a good practice. So this is an example. Write a block that receives the salary of employee 100 in a variable beta, gives the salary 100 in variable v new sal, update employee 100 with this new sal, insert new department called test with ID 1. So this is an example. So we are selecting the salary, the old salary we are printing, view salary is the old salary plus 100, then we are updating the employee with the new salary, then we are inserting into department with a value of 1 and test. So we write from this, the new salary is 24,100. We have increased by 100. Now if we run this statement, 100 and salary is 24,100. So salary is updated in the database table. Also, if we can see that the new department is created, test department. Remember, PL/SQL does not return an error if an update delete statement does not affect any rows in the underlying table. So there is no employee with employee ID as minus 989. So if you write within PL/SQL delete from employees where employee ID is equal to minus 989, it won't give you any error. But it will not delete anything, it will give you any error as well. Select star from employees, the department ID is equal to 20, there are 2 employees. So now 0 is updated, we want to see SQL person count. So if we run this, so see 2 records are updated. So if we run this update statement, 2 records will get updated. Select star from employees by department ID. Here, if we run this statement, contains no records to be retrieved. Here we are updating the employees, setting salary to salary plus 1000 where department ID is equal to 9999. There is no employee with department ID 999. So SQL person found is actually false. So if it is false, it means the SQL contains row records retrieved. So here the SQL contains row records retrieved. So this is about some cursor variables. Cursor variables. Okay, let me do that. So we have covered till chapter 5 till today. We'll continue in the next time. Hi Indu.
Hi, Subrato.
Hi, good morning. Let's continue our session on Oracle 12 CPL SQL. So we already covered 4 chapters, 2, 3, 4 and 5. So today we will cover chapter 6. Chapter 6 is about writing control structure, controlling the flow of execution that consists of if-then statement, if-else then if-else statement, case statement, and loops. So if statement looks as below, as shown on the screen. So if x greater than 10, then do something, then end it. That is the construct. We also have if else, if x greater than 10, do something, else do something, then end it. Then the third one is else if x is equal to 10, then do something, else if x is equal to 9, do something, else if x is equal to 8, do something, end it. Now, in this construct, if the first condition is true, then it won't evaluate the next condition. Suppose x is equal to 10. So the first condition is true, so it will go in the first condition, do something, and then it will come out. It won't go for the, it won't evaluate the second and the third condition. And the fourth one is the complete structure. If x is equal to 10, then do something, else if x is equal to 9, then do something, else if x is equal to 8, then do something, and then we have the default else clause. If none of the above satisfies, then it will go to the else part and execute whatever is mentioned there. So that is about the if statement. Case expression is case statement construct is like case selector, and then when expression 1, then result 1, when expression 2, then result 2. Similarly, we have expression n, then result n, and then finally we have uh, else part, which is the default part. A case statement expression evaluates the condition and returns a value, whereas the case statement evaluates the condition and performs an action. A case statement can be a complete PL/SQL block. Case statements end with end case. Case expressions ends with end. So, considering handling nulls, consider the following example: x is equal to 5, y is equal to null if x not equal to y. Actually, when you are comparing something with null, the result is always undefined or null. So, even if x and y is not equal, but if x not equal to y is always null. So it's always false. It's not true. Similarly, A is equal to B and A is equal to null and B is equal to null. If you say if A is equal to B, then it actually is null or undefined, which is a false. This is a logic table. Build a simple Boolean condition with comparison operator. We have AND, we have OR, and we have NOT. So this is the condition. If we false take precedence in AND condition and true takes precedence in OR condition, meaning that if in an AND condition, if any of the portion if any of the part is false, the result is false. But in OR condition, if any of the part is true, the result is true. AND returns true only if both of its operands are true. If both the operands are true, then AND will return true. OR returns false if both the operands are false. Null and true always evaluates to null because it is not known whether the second operand evaluates true. Null and true always evaluates to null. So any operation with null evaluates to null or undefined. Then we have loops. Loops, we have three types of loops: basic loop, for loop, and while loop. The basic loop looks like this: loop, then end loop, and within that we have the statements, and then we have an exit condition. If we don't have an exit condition, or if the exit condition is not met at all, it will be an infinite loop. While syntax is while, then you give the condition, then loop, and then end loop. Within that we have the statements, our statements. Use the while loop to repeat statements while a condition is true. When the condition is true, it will go inside the loop and evaluate. Once the condition is false, it will come out of the loop. For loop, for loop is a shortcut. Use the for loop to shortcut the test of number of iterations. So for construct do not declare the counter, it is declared implicitly. So for counter in, then you give 1.10 as for example, it will loop 10 times. And then we have the end loop, within that we write our statement. If you use the word reverse, this causes counter to decrement each iteration from the upper bound to the lower bound. So you can say counter in reverse 10.1. So it will start from 10 and it will start in each iteration, it will get reduced to 1, like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that is how for loop. Nested loops you can have nest loops to multiple levels. Use label to distinguish between blocks and loop. Exit the loop with the exit statement that references the label. Nested loop and labels. You can nest for, while, and basic loops within one another. The termination of a nested loop does not terminate the enclosing loop unless exception was raised. However, you can label loops and exit the outer loop with exit statement. Label names follow the same rules as other identifiers. A label is placed before a statement either on the same line or a separate line. White space is insignificant in all PL/SQL parsing except inside literals. Label basic loops by placing the label before the word loop within delimiters, double less than and double greater than. In for while loop, place the label before a for or a while. If loop is labeled, the label name can be included, but it is optional after the end loop statement for clarity. Okay, so let's go to the examples that we have discussed. Let's go to examples of that. Chapter 6. So the first one, we are declaring B number as a number, and it is ampersand B means it will ask for the input. So let's run this. So it will ask for the value of B. So let's say 15. 15. Okay. And the output, the number you entered is greater than 10. So if the number is greater than 10, it will output, it will print the message you entered is greater than 10. Simple if statement with else. Here we have both greater than 10 as well as less than 10. So if we run this, it will say we give a value of 8 this time. So the output is number is less than 10. So we have a if statement here and we have a else statement here, and then of course an ending. Then if else if statement along with the default else part. Let's run this. Let's give it a value of 60 and check what is the output. The grade is D. So between 60 and 69, the grade is D. So it has printed the grade is D. Then this has a nested if else. That means if it is between 0 and 100, then we have the other if condition. That is, if it is 90 to 100, it's grade A. Likewise, and else if it is not between 0 and 100, it comes to the else part and prints the grade should be a number between 100, 0 and 100. So if we run it with a value of 110, it will go to the outer else part and print the grade should be number between 0 and 100. Write a block that takes the employee ID as substitution variable. Output message, yes, salary is greater than 15,000. If salary is greater than 15,000, output message, no salary is less than 15,000 if salary is less than 15,000. So this is the condition. We are selecting salary into a variable from employee where employee is equal to underscore employee. I don't know what is the employee present. Suppose let's try with 100. Salary is, yes, the salary is greater than 15,000. So it has come to this part. So its salary is indeed greater than 15,000. We can of course run that. We can find out. Select salary from employees where employee is equal to 100. So its salary is 24,100. So that is obviously greater than 15,000. So it has printed this log. Then we have this example where x is equal to number 5. It is assigned a value of 5. Y is the number, but it is not defined. But so it is null. So it should print operator with null values is always null. So let's run this. The operator with null values always null. So the solution is use the NVL operator. The NVL operator, if it's a null value, it will assign the other value, like in this case 0. If it is null, it will assign 0. So here it will print welcome. If we run this, it's printing welcome. Similarly here, operator with null values, always null will be printed. We run, that is printed, and the solution is either you use NVL or you use the is null, like if x is equal to null and y is null, then print welcome. Here both of them are null because they have not been assigned any value. So if we run this, then it will print welcome. Okay. So this is a case statement example. We are modifying the salary, multiplying it by 1.1 if when department is 90. When department ID is 60, we are multiplying the salary by 1.2. When department ID is 100, then we are multiplying the salary to 1.3. Else we are giving the salary. This is the new sal. If we run this, so this is the new sal. So in case department is 90, it is 1.1 times. So 24,100 into 1.1 times, that is 26,500. But for say department 30, there is no case clause here because it's only for 90, 60 and 100. For all others is the salary. So 11,000 and 11,000. New salary is also 11,000. So that is a use of case statement. The second one is also a successful. Now let's use the case expression. Let's run this. Employee ID say 100. Salary is high. So 100 we know his salary is 24,100. So it comes to this else part where it says salary is high because it is not falling in any of these conditions. It is 24,100. So it comes to the else part and means salary is, is high. Here we are using here we are using a case statement instead of a case expression. The difference is in the case statement we write the end as end case, whereas in case expression we just mention end. So this is similar to the earlier example. We run it with 100. What happened? Okay. So it means salary is high. That's it. Next. So here is a loop, basic loop. Inside the loop, we are increasing the counter. Counter is P counter is initially 0. We are increasing the P counter by 1, P counter plus 1, and then we are writing printing the message welcome, then with P counter. And we are exiting the loop when P counter is equal to 3. So let's run this. So 1, 2, 3. After 3, we exit the loop. Another method is exit. We are putting a if condition to exit the loop, but it is same as the earlier one, so it will also print the same thing. So same thing. Only instead of exit when v counter is equal to 3, we are writing if v counter is equal to 3, then exit. Print the employee's first name for employees 100, 101, 102. So 101, 102. So we start with employee 100 and we are exiting when it's greater than 102. So if we run this, 100 is Steven, 101 is Nina, and 102 is Lex. So here the exit condition is when it's greater than 102. So with 100 it starts, it comes inside the loop and then it is incremented here. So it becomes 101 and then the next iteration is become 102 and then in the next iteration it becomes 103, but it encounters this exit statement and it comes out of the loop. Okay. 4, 5. Okay. This is a while loop. While v counter less than equal to 3. While it is less than equal to 3, that means it will go inside the loop. Once it is greater than 3, it will come out of the loop. So v counter starts with 1. 1 is less than equal to 2, it goes inside, it prints welcome. Then v counter is increased here, incremented here. It becomes 2. It comes here, checks this condition. It's still less than equal to 3, so it prints another welcome. Then it prints becomes v counter becomes 3. Then also it is true, it becomes, so it will print welcome again. And then v counter becomes 4 here. And when it comes here, it is not less than equal to 3, so it comes out of the loop. So 3 times it will print. 3 times welcome. Print the employee first name for employee 100, 101, 102 using a while loop. Here the condition is while employee number is less than equal to 102. So we start with employee number 100 and at the end we increment it by 1. So 101, 100, 101 and 102 it will print. 100, 101 and 102. Okay. Okay, fine. Then this is a for loop for 1 in I 1 in dot dot 3. That means I will be 1, 2 and 3. So welcome 1, welcome 2 and welcome 3. Welcome 1, welcome 2 and welcome 3. Here I is in 1 dot dot 1, so it will print only one welcome. Welcome 1 only it will print. Welcome 1. Here it is 3 to 5, so it will print 3, 4, 5. 3, 4, 5. Here in reverse 1 dot dot 3, so it will be 3, 2 and 1. 3, 2 and 1 because the reverse word is there. I in 9 by 2, this is interesting. 9 by 2 means 4.5, but it is incremented by 1. So let's see how it works. 1, 2, 3, 4, 5. 9 by 2 is rounded to 9 by 2 is 4.5, but 4.5 is rounded to 5. That's why you see 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then again that example of 100, 101, 102. If we want to print the first name and last name, we can write this in this way. If we run this, so this is 100, 101 and 102. This is using the for loop. Okay. 6, 7. So it is trying to print in this format. So 1 asterisk, 2 asterisk, 3 asterisk, 4 asterisk. Because it is appending to the same v star variable. V star initially is null. Then for I in 1 to 5, for I is equal to 1, j is equal to 1 dot dot I. 1 dot dot I means 1 dot dot 1 in the first iteration of I. So 1 star. In the second iteration of I, it is 2. So it will be 2 star. So if we run this, so this is the output. This is the label we were talking about. This is end loop outer label and this is inner loop. So this is a nested loop. The earlier example with the labels. So this is how you put a label. It gives the same result, same output. This one and this one is same. Here we are using the outer loop. We are exiting the outer loop when I is equal to 3. So inside the inner loop, we are iterating, and when I is equal to 3, we are exiting the outer loop. So even though I is 1 to 5, after 3 execution, it should exit. So just I is equal to 3, it has come out. It has not gone any further. So this is how you can use the labels. Okay. So this just prints 1 to 10. 1 to 10. I want to print the number with the symbol colon parenthesis only for 1, 2, 3, 4, 5. So there are method 1 is this. If I between 1 and 5, then the symbol is I, then char 10, then this symbol, otherwise is I. Then we are of course printing I. So you can 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is normal. Method 2 is continue when I greater than 5. This means stop execute next statement when I is greater than 5. So continue means it won't go execute the next statement, but it will come to the end loop and it will iterate again. So if I is greater than 5, we are not printing this I, but we are only printing this line. So if we run this, so in the next, these are the two lines. This is the first DBMS output, this is the second DBMS output. But after 5, the second DBMS output is avoided using the continue statement. Only the first DBMS output statement is getting printed. So that's pretty much about this chapter, and we will end our section here today. Thank you.
I'll be in mute.
Okay.
Okay, and you can just continue the session. Okay. First of all, obviously, I would like you to to introduce the syllabus and what will be the course objective, what we are going to learn from this course, and then after that, you can start with the proper training. I will keep myself in mute, and then so don't be worried. So still disconnected, but I'll keep myself in mute.
Okay.
Okay.
Yeah.
Perfect. Yes, we can start now.
Okay. Thank you.
Sure. Thank you. Subrata, sorry, one more thing. Please make sure your mailbox or any of the personal details or any client information is not visible in the screen.
Yeah, sure.
Okay.
Yeah.
Perfect. Thank you.
Okay. So let's good morning. Let's start the training on SQL. So first I will go to the syllabus, what we will be learning in this session. So I am opening up the syllabus. So these are the topics that we will cover. Overview of SQL. What is SQL? What is its benefit? Block structure, types of blocks, writing synonymous block, using SQL plus to run anonymous blocks, creating scripts and running. Then the next chapter will be declaring SQL variables. This is about variables and the syntax, defining variable exercise, guidelines for declaring and initializing variables, delimiters, the string literals, the key notation, type of variables and data types size, define variable using person type, understanding the select statement in SQL, find variables. Then the next chapter is writing executable statement. Inside SQL block, nested blocks, SQL SQL present supply packages application development. As you can see, update in PMP says salary is equal to salary plus 100 where department ID is equal to 10. The first use case where we raise the salary by $100. Similarly, we'll have to write 4 different update statements. Whereas in SQL, we'll write a procedure update salary, which will take the parameter department. So we basically covered till chapter 6. So all these chapters we have covered. And now we will be starting from chapter 7. So let's go back to this document. Chapter 7, so that is working with composite data types. Composite data types, they can hold multiple values, unlike scalar type, are of 2 types. One is SQL record and one is SQL collection. SQL collections are of 3 types. One is indexed by tables or associative arrays, one is nested table, and one is VARRAY. The first SQL record. What is a SQL record? A SQL record is a composite data structure that is a group of related data stored in fields. Each field in SQL record has its own name and data type. declaring a PL/SQL record. First option is programmer defined records. Second option is table based record, where we use the percent row type. And the third one is cursor based record, which we will be covering later. So PL/SQL record, first the programmer defined records. To declare programmer defined record, first you have to define a record type using the type statement with the fields of record explicitly. Then you can declare a record based on the record type that you have defined. So here you see this type T_EMP is a record where we have, which consists of V_EMP ID, which is employees.employee ID percent type, B_first name, which is employees.first name percent type, and V_last name, which is employees.last name percent type. Once we define the record of type T_EMP, then we can declare a variable of T_EMP type. Just like we define a variable of scalar data type, similarly we define a variable of the record type. But first we have to declare the record type. And when we declare a variable of record type, it creates a variable which consists of multiple fields. As in this example, it consists of 3 fields. And each of the field will have a name and a data type. PL/SQL record. A record is a group of related data items stored in the fields, each with its own name and data type. Each record can have as many fields as necessary. Records can be assigned initial values and can be defined as not null. Field without initial values are initialized to null. The default keyword can also be used when defining fields. You can define record types and declare user-defined records. In the declarative part of any block, subprogram or package, you can declare and reference nested records. So one record can be component of another record. So, and programmer defined a record, an example where we defined our record T_EMP. We define a type T_EMP, which is a record. It consists of 3 fields: V employee ID, V first name, V last name. And then we define a variable V_EMP as that record type T_EMP. So all these declaration are in the declare part, in the declaration part of the block, and then in the executable part, we are selecting the employee ID first name, last name into the variable V_EMP from employees, where employee ID is equal to 100. And then we are printing the employee ID first name and last name. So that is this example. Table based record, percent row type. Percent row type attribute is declare a variable according to a collection of columns in a database table or view. Prefix percent row type with the table or view. Fields in the record take their names and data types from the columns of the table and view. A syntax is a variable name that reference percent row type. That is the table name. As for example, declare EMP_record employees percent row type. So whatever employees table will have, all those columns will be available in this record type. And the names and the data types of those fields will be similar to the names and data types of the columns in the employees table. So advantages of using %row type. The first advantage, the number and data types of the underlying database columns need not be known and in fact might change at runtime. So if you alter the table to change the data type of the columns, that is implicitly taken care of. The record field will also change its data type and length. The %row type attribute is useful when retrieving a row with a select statement. In a select star, if you use from a table, that fits into the %row type record type directly. There is no coding or any conversion required. It will directly fit into a %row type record type. An example, V underscore DEPT is department's %row type. And then in the executable section, we are selecting the columns of the department's table into V underscore DEPT, where department ID is equal to 10. Then we are inserting into a copy table, copy departments, which has a similar structure of departments table. Sorry. And in the values clause, we are giving V underscore DEPT. So it's a one-to-one straight mapping between the department's columns and the V underscore DEPT fields. Then we come to the next portion, which is PL/SQL collection. As I said, composite data types are of two types, PL/SQL records and PL/SQL collections. We have discussed the PL/SQL records till now. Now we will discuss the PL/SQL collection. The first type is index by tables or associative array. The second type is nested table, and the third type is VARRAY. These are the three PL/SQL collections. So index by table or associative array. Index by table is a PL/SQL structures with two columns, primary key of integer or string data type, and column of scalar or record data type. So basically it has a index and a value. The index or that is the primary key, that is of integer or string data type, and then the value of the value can be a scalar data type like number, varchar, date, or it can be a composite data type, like it can be a record data type also. PL/SQL index by table or associative arrays are unconstrained in size. However, the size depends on the values that the key data type can hold. So it's unconstrained. You can have as many records as you wish, but it depends on the values that the key data type can hold. So here you can see this is index by PLS integer. So you have a key and you have a value. Here the values are scalar data type, like a string varchar 2. An example, type tab number is table of varchar 200 indexed by PLS integer. When you say indexed by PLS integer, the key will be a integer value. The key that this associative array will have is integer. How do you know that this is an associative array? Because there is an index by clause. Whenever there is an index by clause, it means it's an associative array. So as you can see, we are populating in the executable section, we are populating the V tab number index 1, index 6 and index 4 with Khaled Ahmed Jayat. So they are stored in the picture which is shown in the right in green. In similar way they are stored. Then we are printing those values. There are a couple of methods for the associative array. The following are the methods like exist, count. Exist will return a boolean which will say whether whether the record at the particular index exists. Count will give the count of the total number of records in the array. First refers to the first record, last refers to the last record, prior refers to the record prior to the current record, next refers to the record next to the current record, and we have a delete option to delete a record. Like exist within bracket n, return true if nth element in a PL/SQL table exists. Count returns the number of elements that the PL/SQL table currently contains. First, return the first index, smallest index in the PL/SQL table. Returns null if the PL/SQL table is empty. Last returns the last or the largest index number in a PL/SQL table. Returns null if PL/SQL table is empty. Prior n returns the index number that precedes index n in a PL/SQL table. Next n returns the index number that succeeds index n in the PL/SQL table. Delete removes all elements from the PL/SQL table. Delete n removes the nth element from PL/SQL table. Delete m comma n removes all elements in the range m dot dot n from the PL/SQL table. So these are some of the methods that are available to work on associative array. There is an example of type of table of index by table of record, associative array of records. Here we are declaring in the declarative section, we are declaring type tab number, which is a table of person employees person row type, which is nothing but a record, and indexed by PLS integer. So it's an associative array which will contain the employees row type. So we define a variable of that data type tab underscore no, and then in the executable section, as you can see, with the index dot field name. This field name is employees person row type. So all the columns in the employees table are available in the fields. So we are using only the employee ID, first name and last name. And then we are printing the employee ID, first name and last name. The next thing is, of course, a nested table. An example is location type is table of location dot city person type. Then we say office's location type. We declare a variable of that type. There is no index in index nested table, unlike index by table. It is a valid data type in SQL, unlike index by table, which is only in PL/SQL. Remember, associative array is only a PL/SQL entity. In SQL, you cannot use an associative array. But nested table is valid data type in SQL also. Initialization required, extend required, can be stored in DB. PL/SQL tables cannot be stored in DB, but nested table can be stored in DB. Here is an example. Location T underscore locations is a table of varchar 200, a scalar data type, and lock is a variable of that type. Then lock we are calling T location and initializing the values Jordan, UAE, Syria. Then we are printing the values of location 1, 2, and 3. Next is VARRAY. Similar to nested table. An example, VARRAY is constrained by a size like VARRAY 3. It will only contain 3 records. So we are inputting 3 records and printing them. So here is a comparison between PL/SQL table, nested table, and VARRAYs. Associative array, number of elements is unbounded. Subscript type is string or integer. It can be string or an integer. Dense or parse it can be either dense or parse. Only in PL/SQL block scope. Can be object type attribute? No. Nested table, that is also unbounded, and the subscript type is integer. It starts as a dense, can become sparse. It is used in PL/SQL block or at the schema level. It can be an object type attribute. VArray is bounded, not like the other two which are unbounded, but VArray is bounded. At the time of creation, you specify the size of the VArray. Subscript type is integer. VArray is always dense. It is either in PL/SQL block or schema level, and it can be used as object type attribute. Okay, let's now see some examples of what we discussed till now. So here TEMP, this is a record type containing of 3 fields. Then this is a variable of type TEMP. Then we are using the select for employee ID 100 and putting it into these fields. Then we are printing them. Let's run this. So 100 Stephen King. Employee ID, first name, last name. The next example is TEMP is the record of similar employee ID, first name, last name. Then we are declaring a variable of type TEMP. Then we are selecting and printing the values. This should give a similar output as the earlier one, same output. Here TMP is a record of type employee ID, first name, last name. Then VMP is of type TMP for 100, for I in 100 to 103. That is 100, 101, 102 and 103. Where employee ID is equal to I, that means it will contain employee ID 100, 101, 102, 103, and then it will print the values. Let's run this. So 100, 101, 102, 103. These are printed. Okay. So we are selecting department ID, department ID 10, select the star from department. So it's administration department, manager ID 100, location ID 1700, and department ID 10. Then we are creating a copy departments. Copy departments, for select star from departments, where 1 is equal to 2. 1 is equal to 2 means it's false. So there won't be any record. But the structure of the department, copy department, will be similar to structure of the departments. Let's select, it's same as the departments table. Then we are declaring T department is a record of department ID, department name, manager ID, location ID. Then V department is a variable of type T department. Then we are selecting the department ID, department name, manager ID, location ID into V department, where department ID is equal to 10. Then we are inserting into copy department values V department. So if we do this, now if we select from copy department, we should see a record, right? Let me roll back this, yes. Here there is a update department. We are using % row type in the update. So V department is department % row type. We are updating V department, department ID is equal to 10 and department name is equal to test. Then we are updating the copy departments with these values. Run this. Now if we run this copy department, we have insert. I rolled back the changes, so that's why I shouldn't have rolled back. Okay, let's run this. First, let's run this. Now let's run this. Now let's run this. So you see the department name is 10 and department ID is updated to 10. Okay. So here we are dropping a table, EMP tail, tabular view does not exist. Then we are creating a table, EMP underscore tail, creating. Then inserting a record into this table. Then we are selecting from the table. So this is the record. Then we are creating a T underscore tail is a record of mob1, mob2 and landline person type. Type EMP, TEMP tail is a record which consists of employee full name and T-tail. That means this is a nested, this is a record which contains another record. Then we are setting VDEC variable as this record type. Then we are selecting where employee is equal to 1. So we are selecting our record and we are printing the values. So let's run this. So employee ID 1, landline, you get the landline number. So employee ID and landline we are printing. Let me roll back. So this one done. Next. This part 3. This is table of varchar 200 indexed by associative array. This is an example of an associative array. This is straightforward. Let me execute this. So we are printing the names. This is a table of associative array of numbers. So let me execute this. So these numbers are output here. Here 100, 101, 102 to 110. So all the employees we are putting into first name concatenated with last name that we are putting into the associative array, and then we are printing the associative array. So let's run this. So these are all the names, 10 names. Okay. Here we are using some of the functions of associative array like exist. So we have an array which index 1, 2, 3, 4 is missing, 6 and 5. So for 4 it will say is not exist in the array. So let's run this. So 1, 2, 4 it says is not exist in the array, but others exist in the array. 7, 8, 9, 10 is also not in the array. Then the first element, last element. So we are using the first, the next 3 and the exist method here. So this is a employees person row type example. This is a table of person row type. associative array, table of person, row type. So here we are setting the employee ID, first name and last name for 2 records, and then we are printing them. So this is the output. Here we are doing for 100, 101, 102, 103, 104 the values. So if we run this, so 100, 101, 102, 103, 104, we are getting the values. Here we are using the first and the last, and we are iterating to print the values. So let's run this. So this is the output. Here printing everything in separate lines. So each record will have 4 lines: employee ID, first name, last name, salary. The employee ID, first name, last name, and this is the salary. This is record 1, this is record 2, this is record 3, this is record 4, and this is record 5. Okay. This is a nested table example. So we are printing the values. So USA, UK, Jordan. Here we are using the first and last method of the nested table. This is a nested table because there is no index by clause. So if we run this, USA, UK, Jordan, then you see in the nested table, we can extend the table. So here we are extending the table and setting the value to labor none. So if we run this, we should get 4 records. There you go, we get 4 records with labor none as the last record. Then here we are deleting two, we are deleting the record, the second element of the nested table. This Iraq, Syria. How to use in SQL? Let's okay. Create or replace type table of number. This is a nested table we are creating in the database. Then we are creating a table with with that data type. Then we are inserting some records. And now if we are selecting from this table, we see a collection. And if we click on this collection, we see the column values. Okay. This is a V array of 3. This is the example of V array. It's the output. You cannot extend V array, it will give an error. So if we see location.extend, so V array is bounded, it's not unbounded. So it will give you error if you try to extend the V array. But you can use a trim function to delete the V array. So if we want to delete, we can delete. So one is deleted. So how to use in SQL? Let's try this. Okay, because this window is running, to close this window. Then let me. This was some locking issues coming. So why it's coming? Because to roll back. Now let's try this. Okay. Then we are at 10. We are creating replacing type. Then we are creating a table where we have V array as a column. So create. Then we are inserting into the nested table also. And then if we do select star from customer, we have a collection. And if we check, we have these fields as a collection. That's pretty much it. Okay. Next, we will move on to our next chapter. Give me 5 minutes break. I will be back in 5 minutes. Okay, I need to take an half an hour break. Uh, we will start after half an hour. I know I completed one chapter. Can you put it on hold? I will start after half an hour. I have some work. Yeah, put it for hold for half an hour. I will be back. Oh, thank you so much. Hello. Hello, Indu.
Hi,
Hello.
Shagita.
Hi, Indu.
Hello.
Yeah.
Yes, we can start.
Okay, I'm starting.
Yeah,
Okay.
I'll keep myself on mute.
Okay, sure.
Yeah. Okay.
Hi, good morning. So we just completed composite data type. We just completed this chapter. Now, next we'll move on to the next chapter, which is explicit cursors. Using explicit cursors. So cursors are every SQL statement executed by Oracle server has an associated individual cursor. There are two types of cursors. One is implicit cursors, declared and managed by PL/SQL for all DML and PL/SQL select statements. So this is implicit cursor. We don't have to do anything regarding this. Oracle server takes care of this automatically. And then we have explicit cursors, which is declared and managed by the programmer. Explicit cursor operations. You can declare explicit cursors in PL/SQL when you have a select statement that returns multiple rows. You can process each row returned by the select statement. Explicit cursor functions can perform row by row processing beyond the first row returned by a query, keep track of the row that is currently being processed, enable the programmer to manually control explicit cursors in PL/SQL block. Controlling explicit cursors. So we declare the cursor, then we open, then we fetch till it is empty. Once it is empty, we close it. Till it is empty, we go to the next row. There are some explicit cursor attributes like percent is open, evaluates to true if the cursor is open. Percent not found evaluates to true if the most recent fetch does not return a row. Percent found evaluates to true if most recent fetch returns a row, complement of percent not found. And percent row count evaluates to the total number of rows returned so far. Do not include a into clause in the cursor declaration because it appears later in the fetch statement. If processing rows is in a specific sequence is required, then use the order by clause in the query of the cursor. The cursor can be any valid statement including joins, subqueries and so on. So an example, cursor EMP department 20 is select employee ID first name from employees where department ID is equal to 30, order by first name. So this is an example of a cursor declaration. Opening cursor, the open statement executes the query associated with the cursor, identifies the active set and positions the cursor pointer at the first row. The open statement is included in the executable section of PL SQL block. Open in an executable section that performs the following option. Dynamically allocates memory for the context area, passes the select statement, binds the input variable, sets the values of input variables by obtaining their memory address, identifies the active set, the set of rows that satisfies the search criteria. Rows in the active set are not retrieved into the variable when open statement is executed. Rather, the fetch statement retrieves the rows from the cursor to the variables. Positions the pointer to the first row in the active set. If a query returns no rows when cursor is open, PL SQL does not raise an exception. You can find out the number of rows returned by the explicit cursor by using cursor name %row count attribute. Fetching data from the cursor. The fetch statement retrieves the row from the cursor one at a time. After each fetch, the cursor advances to the next row in the active set. You can use %not found attribute to determine whether the entire active set had been retrieved. The fetch statement performs the following operations. Reads data for the current row in the output PL SQL variables, advances the pointer to the next row in the active set. Closing the cursor, the close statement disables the cursor, releases the context area, and undefines the active set. Close the cursor after completing the processing of fetch statement. You can reopen the cursor if required. A cursor can be reopened only if it is closed. If you attempt to fetch data from a cursor after it has been closed, then an invalid cursor exception will be raised. Although it is possible to terminate PL SQL block without closing cursor, you should make it a habit to close any cursor that you declare explicitly to free up resources. There is a maximum limit on the number of open cursors per session, which is determined by open cursors parameter in the database parameter file. Open cursors is equal to 50 by default. So here is an example. First we declare the cursor. This is the cursor declaration. Select employee ID first name from employees where department is 30. Then there are two variable declaration. Then we are opening the cursor. Then in the loop we are fetching into this variable and we are exiting the loop when the person not found is true. And we are printing the employee number and the first name, and then finally we are closing the cursor. So this is a flow of cursor execution. We have a cursor for loop also, which is very common in programming PL SQL. The cursor for loop is a shortcut to process explicit cursors. Here implicit open, fetch, exit and close occur. The record is implicitly declared. The construct is like from employee EMP record in CM cursor. First we declare CM cursor and then we do a for loop for imp record in C employee cursor, then loop and loop. Remember that in CM cursor here instead of CM cursor you can make it inline. That means you can write the select statement directly in this place. Cursor with parameters. Cursors can take parameters. Parameter data types are same as those of the scalar variables, but you did not give them size. You can pass parameters to the cursor that is used in a cursor for loop. As for example, CM cursor, P department number, P job these are two parameters. Is the select statement will follow, and then in the for loop you can pass on these parameters. Using for update for cursor. For update clause is always the last statement in the select. When you use a for update, it uses an explicit locking to deny access to other sessions for the duration of the transaction. Locks the row before the update and delete. If you want to do an explicit locking so that other sessions cannot access the same row and try to update, so you can do a for update. Where current off, use the cursors to update or delete the current row. Include the for update clause in the cursor query to lock the first row. Use the where current of clause to reference the current row from the explicit cursor. So that's about cursor. So give me 1 second, please. Okay, now let's move on to some examples of what we have learned so far regarding cursors. So first, let's do a select from employees where department ID is equal to 30. So this is the output. Then method 1, create cursor to print employee ID first time for department ID 30. So here we are opening where we are opening a cursor. This is a cursor name, and these two are just two variables. Then we are opening the cursor, fetching the cursor into this name, exit when not found, and we are printing the name. So let's run this method. So we see all the departments, and in department 30, employees in department 30 are printed. Method 2 is we are declaring a cursor for department 30. Then we are opening, fetching, then exit when not found, and then we are printing the employee ID and the first name. So same output. Here we are using a record of cursor percent row type, and we are printing from the record the employee ID and the first name. Same output. We are increasing the salary of employees in department 30 by $100. So this is the cursor declaration. These are some variable declaration. Then we are opening, fetching the value, and exit when not found. Then we are updating the salary. So the salary has been increased by $100. for all the employees in department 30. Okay. So here we are using not found, percent is open, percent row count. So what we are doing is we are declaring a cursor by selecting all the employees from employee table. If cursor is open, then null, else open CAMP. Then we are doing a CMP percent row count. Then fetch, we are fetching into V employee name and first name. Then exiting when CMP percent not found or CMP percent row count 10. So it's only going to print the first 10 records. Let's run this. So counter is now 11. So on the 10, so first the counter is 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and on the 11, the cursor we have already exited when it is 11. We are not printing the 11th record. So this is a basic loop structure. Basic loop cursor. This is a basic loop cursor which we have already learned. And here is the for loop example. For loop cursor. That's the example. So first we are declaring the cursor, then in a for loop, we are here open, fetch, close, everything is taken care of by the for loop cursor. So it's very convenient to use the for loop cursor. As I said, you can also write the select statement inside the for loop. This is the most used way of using cursors. So here, instead of declaring the cursor separately, we are writing the select statement here only. And then we are doing the for loop. Okay. Here are some examples of cursors with department, where V department number is a parameter of type number. This is a parameter, cursor parameter. So when we are opening the cursor, we have to open it with a parameter. So we are opening it with parameter 10, department 10 and department 20, and then printing the employee and the first name. So let's run this. So this is department 10 and this is department 20. This is the same example but with a for loop cursor. So here we are opening in the for loop, we are opening the cursor with department 10 and here with department 20. So it's the same thing, only using for loop. Same output. Okay. This is a normal select start from employees where employee is 100 and 200. So 100 100 and 200. This is for update. So we are selecting the records for update. Immediately you see this arrows have become, because this select statement has locked the record. So we have to either commit or roll back. So we commit. Yeah. So here is an example. Increasing salary by $1. Increase the salary by $1. All the salaries are increased by $1. And here it uses the where current of syntax. So let's run this. So again, the salary is reduced by $1 here. So earlier we increased by $1, so one was appearing here. Now we have decreased by $1. So that's pretty much about cursors. Then we will, the next chapter we will cover ending exceptions. But before that, we will take a 2 minutes break and then come. Hello. Okay, let's proceed with handling exceptions, the next chapter. So this is a PL/SQL block structure. We have a declare, begin, and then an exception section. Here we handle an exception. This is an optional. This is an optional part of the PL/SQL block. But to handle exception, we have to include this part. Example of an exception. Select last name into a VEL name from employee where first name is equal to John. There are more than one employee for the first name. So if more than one employee for the first name, it will result an exception. Exact page returns more than requested number of rows. So to handle that, we write this when too many rows, then we print a message, your select statement retrieve multiple rows considering using a cursor. So this is how we handle the exception. Unlike earlier, the PL/SQL program does not terminate abruptly. When the exception is raised, the control shifts to the exception section and all statements in the exception statement are executed. PL/SQL blocks terminate with normal successful completion. So in this case, in the earlier case, you will get an error like this as shown here, and the PL/SQL program will terminate abruptly, showing an Oracle error. But here the Oracle error won't be shown, but whatever message, how we have handled the exception, that we have printed a message, so that message will be printed and PL/SQL program will complete successfully. Handling exceptions with PL/SQL, an exception is a PL/SQL error that is raised during program execution. An exception can be raised implicitly by Oracle server or explicitly by the program. An exception can be handled by trapping it with a handler or by propagating it to the calling environment. Exception types, there are 3 types of exceptions. Predefined Oracle server exceptions. There are approximately 20 errors that occur most often in PL/SQL code. You need to declare these exceptions. They are predefined by Oracle server and are raised implicitly. Non-predefined Oracle server exception, any other standard Oracle server error You need to declare this within the declarative section. Oracle server will raise the error implicitly, and you can catch the error. You can catch for the error in the exception handler. And user-defined condition, a condition that developer determines is abnormal, declared in the declarative section and raised explicitly. So trapping exceptions is in the exception block. You can have multiple exceptions. But the last one is a good practice to keep when others. This is an optional exception handling clause that traps any exception that have not been explicitly handled. So it's a good practice to keep when others in the exception block. The exception keyword starts the exception handling section. Several exception handlers are allowed. Only one handler is processed before leaving the block. When others is the last clause. Predefined Oracle Server exceptions are like no defined, no data found, too many rows. No data found is when your open select statement is not returning any record. So in that case, no data found exception will be raised. Or if your select into statement is returning more than one record, so in that case, too many rows exception will be raised. If your cursor is closed and you are referring that cursor, invalid cursor exception will be. Zero divide is if you are dividing something by zero, then zero divide exception will be raised. Do well on indexes. If you are trying to insert a record, duplicate record into a table, then do well on index will be raised. Predefined exceptions. These are some of the predefined exceptions. A full list. This is another continue. Trapping non-predefined exception. Non-predefined exceptions are similar to predefined exceptions, however they are not defined as PHSQL exception in the Oracle server. They are standard Oracle errors. You create exception with standard Oracle errors by using pragma exception in it. Such exceptions are called non-predefined exceptions. You can trap non-predefined Oracle server errors by declaring it first. The declared exception is raised implicitly. In PL/SQL, pragma exception in it tells a compiler to associate an exception name with the Oracle error number. That enables you to refer to any internal exception by name and write it to specific handler. So we have a declare, we have an associate with pragma exception in it, and then in the exception handle we have a reference where we handle the exception. An example, here we define a insert exception as a non-predefined exception, and then we have a pragma exception in it to associate it with -01400. Then insert into department, we are trying to insert this exception, and when third step is when this exception occurs, we are printing the message insert operation failed and SQL error. That is the error message. So Oracle server error -01400 is cannot insert null. So in the department name we are trying to insert null, so this exception will be raised. We have associated it with insert except, and then in the exception handling, when insert except, we are printing some message. Remember, SQL code returns a numeric value for the error code, and SQL ERRM returns a message associated with the error number. These are two handy handy codes available to print the actual error, server error. User-defined exception is similar to non-predefined exception. In the declarative section, you declare the exception, then you raise the exception explicitly with the raise statement, and then you handle the exception. Trapping user-defined exception, the PL/SQL enables you to define your own exception depending on the requirement of your application. For example, you may prompt the user to enter a department number, define an exception to deal with the error condition in the input data, check whether the department number exists. If it does not, then you will have to raise a user-defined exception. PL/SQL exceptions must be declared in the declarative section of PL/SQL block, raised explicitly with the raise statement, and handled in the exception section. Here is an example. E-invalid department is an exception, user-defined exception. So we are updating department number. We are updating department, setting the department name to V name, and where department ID is going to be department number. That is 500, and name is testing. Raise E-invalid department if SQL person not found. If the department does not exist, we are raising an E-invalid department exception. This is a user-defined exception. Then in the exception section, we are handling the E-invalid department by printing the message, no such department ID. Raise application error procedure. You can use this procedure to issue user-defined error messages from your stored program. You can report errors to your application and avoid returning unhandled exception. So instead of returning an unhandled exception, we can raise application error with error number and message, and that will be reported to the calling environment. So error number is user-defined number of exception between -20,000 to -20,999. Message is a user-defined message exception, characteristic of 2048 bytes. True false is the optional Boolean parameter. If true, the error is placed on the stack of the previous errors. If false, which is the default, the error replaces the previous errors. There is application error procedure used in two different places. One is executable section, one is the exception section. Returns the error condition to the user in a manner consistent with Oracle server errors. An example, delete from employees where manager is equal to v_manager. When SQL person not found, we are raising an exception. This is not a valid manager. Or in the exception section, when no data found, suppose we are doing a select statement, and when no data found, we are raising this exception. Okay, let's look at some examples of what we learned so far. So let's run this block without exception. No data found, so it bombed. Second solution is to handle it in exception. We have added the exception section. When no data found, we are printing a message. So this program will run gracefully, and output is the query doesn't retrieve any record. When there are many exceptions, you can try with Suppose I see ABC. So here the output is the query does not retrieve any record. Next, let's try it with John. The query retrieves more than one record. So where from these are coming? These are coming from these exception handling. When no data found, we are saying the query doesn't retrieve any record. When too many rows, we are printing the query retrieve more than one record. And then, of course, the other error, when others. So this statement is wrong. This code is wrong because exception the exception will be raised in a for loop and the exception is handled outside the for loop. So if we run this, nothing is printed. So this is not a correct way of handling exception. The correct way is this one, where we have the for loop. Within that we have a begin and exception block. So this is the correct way of handling exception. Okay, let's move on to the next. Okay, so insert into departments, department ID, department name, we are insert. We are getting a message cannot insert null into department name. This is a server message. Within SQL, if we write within begin end block, same message we are getting. So here it's a insert exception minus 01400. So if we run this, here exception is handled. We are using pragma exception in it to insert to associate with minus 01400 and then we are handling that exception. So if we run this, cannot insert none. So it has run gracefully and the program has completed successfully and it has come to the exception section and where insert is handled. So insert fail minus 1400, then cannot insert null. Okay. And also here we are using SQL code and SQL ERRM. So you have seen the use of SQL code and SQL ERRM. So here we are writing an insert statement, then we are updating the employees table, and then we are catching the exception. So this is not correct because if there is an error in the first insert statement, then the update statement will not occur. So this is the correct code. So we have begin exception handling within each of the statements. So they are atomic. So this is the correct way of handling the exception. Okay. So if we do select start from employee, there is no record with employee ID 1. So we will come to know the SQL % row count of this update statement. So if we run this, it's 0 because there is no employee with employee ID 1. Here we are declaring employee ID as 1 and invalid number exception we are declaring. This is a user defined exception. So if SQL we are raising invalid number, and then in the exception block we are printing this SQL code, SQL ERM and a custom message invalid employee ID. So this should get printed. So let's see. Yeah. User defined exception code is SQL code is 1, SQL ERM is user defined exception, and this is the invalid employee ID. Invalid employee ID. Okay. Then this is an example of raise application error. Here we are using raise application error. So here the error is propagated to the calling function, to the calling application. So that is the purpose of raise application error. Select staff from employees when employee is equal to 15154. There is no such employee. So sum salary, department ID is equal to department number. Department ID is 888. So let's run this. The sum is null. So there is no department with department ID 888. So if we run this, 888, sum is 1. Sum is null and count is 1. So there is one department with count is 1 because this is a sum. Sum will always return a count, so it won't go to no data found. This is not a normal select statement. This is a sum, so the count is 1, but the sum salary is 0. Okay. Next, let's move on to the next chapter, creating procedure. Let's move on to the next chapter, creating procedure. So as we told earlier also that PL/SQL, there are 3 types of PL/SQL block. One is the anonymous block, the other is a procedure, the other is a function. So procedure and functions are subprograms. They can be stored inside the database. That is the reason it is called a stored procedure. So difference between anonymous block and subprograms. Anonymous block unnamed PL/SQL block, subprograms are named PL/SQL block. Anonymous blocks are compiled every time. PL subprograms are compiled only once. Anonymous blocks are not stored in the database. Subprograms are stored in the database. Anonymous block cannot be invoked by other applications. Subprograms are named and therefore can be invoked by other applications. Anonymous blocks do not return value. Subprograms called functions return value. Anonymous block cannot take parameters, but subprograms can take parameters. So an example of subprogram is if you want to update the salary of employee, you can either write multiple update statements with each employee ID, or you can create a procedure, update employee, and you take the employee ID as a parameter and the amount to be added to the salary as a parameter, and you can write a single select statement, a single update statement. So by calling this procedure multiple times with different parameters, you can update the salary of different employees with different amounts. So modularizing development will PL/SQL blocks. PL/SQL is a block structured language. The PL/SQL code block helps modularize code by using anonymous blocks, procedures and functions, packages, and database triggers. These are the way in which we modularize the PL/SQL code. The benefits of using modularized program construct are easy maintenance, improved data security and integrity, improved performance, improved code clarity. So what is the benefits of anonymous block? First of all, writing trigger code for Oracle Forms component, initiate calls, procedure function packages, isolating exception handling within a block of code. What are PL/SQL subprograms? PL/SQL subprogram is a named PL/SQL block that we call with a set of parameters. You can declare and define a subprogram within either a PL/SQL block or another subprogram. A subprogram consists of a specification and a body. A subprogram can be a procedure or a function. Typically, you use a procedure to perform an action and a function to compute and return a value. So what are procedures? Procedures are a type of subprogram that performs an action, can be stored in a database as a schema object, promote reusability and maintenance. Creating a procedure, we create or edit procedure. If there are errors, we view and compile the warning errors, and again try to compile it. Again try to create the procedure so that there is no compilation error. When there are no compilation error, we execute the procedure. Here is an example: create or replace procedure, update cell, PMID in number parameter. In is the parameter mode and number is the data type. P amount in number. So these are the two parameters. Of course, the parameters are optional. Then there is a word is or as. This is a syntax. Yeah, as per the syntax, you have to use is or as. And after that, we write the begin statement. But before is and begin, there is a declarative section where you can declare variables. Here we don't have any variables to declare, so it's empty. Then within the begin block, we update the employees. Set salary is equal to salary plus P amount, where employee ID is equal to PMID. the two parameters that we are passing, we are using them, then we are doing a commit. Then we are having an exception section where we have when others, we are printing the SQL code and SQL error. So you can call this procedure by writing execute update salary 150. 100 is the department employee ID and 50 is the amount. Or within a begin end block of PL SQL, you can call this procedure. Parameter passing mode. In parameter mode provides a value for a subprogram and to process. An out parameter returns a value to the caller. In-out parameter supplies input value which may return an output value or a modified value as an output. Parameter mode are specified in formal parameter declaration after parameter name before its data type. The in mode is default if no mode is specified. Comparing parameters mode, in is the default mode, out and in-out must be specified. Value is passed into the subprogram in and out is returned to the calling environment. In-out is passed into the subprogram, returned to the calling environment. Formal parameter acts as a constant. In case of in, out is uninitialized value and in-out is initialized value. Actual parameter can be literal expression constant or but out and in-out must be variable. Can be assigned a default value, cannot be assigned a default value, cannot be assigned a default value for out and in-out. There are three notations: positional, named, and mixed. Positional lists the actual parameters in the same order as the formal parameters. Named is lists the actual parameters in arbitrary order and uses the association operator. Association operator is equal to greater than symbol. So that is used to associate the named formal parameter with its actual parameter. And the combination of these two is called mixed. Then you can use the default option. Using the default option defines the default values of the parameter, provides the flexibility by combining the positional named parameter passing syntax, positional and named parameter passing syntax. So here add underscore dept. This is a procedure. P name is equal to department name person type colon equal to unknown. P location we are giving a default as 1700. So when we are calling add department, we can call without any parameter, passing any parameter. So department name will be unknown and location will be 1700. Next one we are passing advertising as a positional parameter, and this is a name method of passing a combination of these two. That is a mixed mode of passing parameters, and then the last one is the named mode where we are passing the location as 1200. Default values used only in parameters. Only in parameters you can specify the default values. If no mode is specified, then it means that it is the in parameter. Handling exceptions. So we are calling the program 2 within program 1, we are calling program 2, and then we have an exception. So in case of exception, the control returns to the calling procedure. When you don't handle exception, then the control to exception section of the calling procedure. If you don't handle exception, then the exception will be propagated to the exception section of the calling procedure. Okay. Let's look at some example of what we have learned so far. So this is an example how you create a procedure. So we run this, then it says executing. Let me close all this. This was the problem. Okay. Okay. So if we create a procedure, okay. So this is how you create a procedure. You can, so the procedure is created. Now you can execute the procedure, imply the 100, and this is 50. If we execute, this is done. So, test select. So the salary had been increased by 50. You can also call the procedure in this way. So we have completed till chapter 10. Let's continue with chapter 11, creating functions. So function is a named PL/SQL block that returns a value, can be stored in the database as a schema object or a repeated execution, is called as a part of an expression or is used to provide a parameter value. Examples, we can create function to return the salary of an employee, function to retrieve the full name of employee, function to calculate the GBPA for the student, function to compute the tax for the salary. All these are the examples of functions. So creating function is create or replace function name, then the parameter list, and then we have a return keyword, return data type, then we have is or as, and then a declare section, begin section, and end. So this is how you create a function. Difference between function and procedure. Procedure executes as a PL/SQL statement. Function is invoked as a part of an expression. Procedure do not contain return clause in the header. Function must contain a return clause in the header. Procedure can pass value using output parameter, and a function must return a single value. Can contain a return statement without a value, must contain at least one return statement. So this is to perform an action, procedure cannot be used in select statement. Function can be used in select statement, but it should not have an out or in-out parameter. If a procedure have one out parameter, then it would be better to be rewritten as a function. So creating the function is the same thing. We create the function. If there are compiling errors, we go back and correct them and try to compile again. Once it is successfully compiled with no errors, we invoke the function. This is an example. This is an example. GetSal is a function where we pass in employee ID and it returns a number. Is we declare a variable vsal, then we select the salary from employees where employee is equal to the parameter pempid, and then we return vsal. So function must have a return statement. Advantage of user-defined function is SQL can extend SQL where activities are too complex or too awkward or unavailable with SQL, can increase efficiency when used in the where clause to filter data as opposed to filtering data in the application, can manipulate data values. These are advantages of user-defined functions. Calling user-defined function, and the user-defined function has a built-in single row function and can be used in select list or clause of a query. Conditional expressions of the where and having clauses. Connect by, start with, order by, group by clauses of a query. Values clauses of an insert statement. Set clause of an object statement. In all these places, you can use a function. There are some restrictions when calling functions from SQL expression. User-defined functions that are callable from SQL expression must be stored in the database, except only in parameter with valued SQL data types and not PL/SQL specific types, right? Record, table, boolean, you cannot have them as in parameters. Return a valid SQL data type and not PL/SQL specific type. When calling function in the SQL, parameter must be specified with positional notation. You must own the function to have or have execute privilege. Cannot be used to check constraint. Cannot be used as a default value for a curve. Functions cannot be used in these two cases. Controlling the side effects when calling function from SQL expression. Function called from a select statement cannot contain DML statements. It cannot contain a DML statement. An update delete statement on a table T cannot query or contain DML statement on the same table T. SQL statements cannot end transaction. That is, it cannot execute commit or rollback operations. Call to a subprogram that break these restrictions are also not allowed in the function. When a function is called from update delete, then the function cannot query modify database table mentioned by that statement. The error you get is mutating table. When a function is called from update delete, then the function cannot query modify database tables modified by the statement. By that update or delete statement, the function cannot query or modify that database table. So let's see some examples of functions. So here we are creating a function which takes employee ID as a parameter, and so we execute this function. So done, the function is created. Now we are calling it as a part of expression. So this is as a part of expression, we are calling this 24,150. As a parameter value, we are calling it 24,150. We can also do this. So it won't work in SQL developer, you have to run this in SQL Plus. You can run this of course here, I think so. No, you cannot run this here as well. Okay. Let's try to run this. Here it runs. Also this one, I don't know whether it will run or not. Yeah, here it is working. So this is how you can call for the function. You can also call as part of select statement. So you can see that as a part of select statement, you can call this function. If from user source you can get the line and text. This is the text. It's stored in the data dictionary table user source. So if we run this, we will get a no data found exception. No, we don't get that. Because function don't have exceptions. No data found exception in a select query is not raised in the select query because the function does not have exception. If we create a replace function, this one, then we do this, then we get -1. Here we are not getting that because there is no exception handled in the function. So that's pretty much about functions. We'll continue with the packages from tomorrow. So that's it for today. Thank you. Good morning. So we have covered till chapter 11, creating functions. That was the last chapter we did yesterday. So we will continue with the next chapter, which is creating packages, chapter 12. So, creating packages. So what are PL/SQL package? A package is a schema object that groups logically related PL/SQL types, variables, and subprograms. A package usually have two parts, a specification and a body. The specification is the interface to the package. It declares the types, variable, constant, exceptions, cursors, and subprograms that can be referenced from outside the package. The package body defines the queries for the cursors and the code for the subprogram. Enable the Oracle server to read multiple objects into the memory at once with the help of a package. Advantages of using a package. First one is modularity, encapsulating related constructs, easier maintenance, keeping logically related functionality together, easier application design, coding and compiling the specification and body separately, hiding information. Only the declaration in the package specification are visible and accessible to the application. Private constructs in the package body are hidden and inaccessible. All coding is hidden in the package body. Creating package specification, the construct is using the create package statement, create or replace package name, then is or as, then public type, variable declaration, subprogram specification, then end package name. The or replace option drops and recreates the package specification. Variables declared in the package specification are initialized to null by default. All the constructs declared in the package specification are visible to the users who are granted privileges on the package. Creating the package body. After we create the package specification, we have to create the package body. Create or replace package body, then the package name is on as, private type, variable declarations, subprograms, bodies, then begin and end. Within the begin and end, we have the initialization statements. The or option drops and recreates the package body. Identifiers defined in the package body are private and not visible outside the package body. All private constructs must be declared before they are referenced. Public constructs are visible to the package body. Guidelines for writing packages. Develop packages for general use. Define the package specification before the body. The package specification should contain only those constructs that you want to be public. Place items in the declaration part of the package body when you must maintain them throughout a session or across transactions. The fine-grained dependency management reduces the need to recompile referencing subprograms when a package specification changes. The package specification should contain as few constructs as possible. These are the guidelines. Guidelines for writing packages. The package specification should contain as few constructs as possible. Try to keep the package specification as simple as you can. As for example, here some procedures are declared in the package specification, and in the package body those procedures should be added. The code of those procedures should be added. Try to add additional codes you need in the package body as private subprogram. Here procedure check before insert, check before delete, these two are private because they are not declared in package specification. So they are private and only accessible in the package body. Visibility of package components. So in the package specification of p underscore test, we declare a variable c var1 and c var2. C var1, var2 can be referenced any place in the package body. C var3 can be referenced in any place in the package body. C var3. C var4 can be referenced only in the print procedure because it is defined within the print procedure. So this is how we execute a package. Execute p underscore test dot print. We execute the procedure of a package body in this way. Dictionary tables and dropping the package body. Select star from user object where object name is equal to p underscore test. Select star from user source where name is equal to p underscore test and type is equal to package. Select star from user source where name is equal to ptest and type is equal to package body. To drop a package, we use the command drop package p underscore test. This drops the specification as well as the body. To drop only the body, we specify something like drop package body p underscore test. So that's it about packages. Now let's see some examples of what we learned. Well, So this is a function, standalone function, which calculates the square of calculate the square area. So we can create this function created. Now if we say select star square area 4, we say get 16. Then another is a function with rectangle area. To calculate the rectangle area, let's create this back function. Then we can run this function. Now because these two functions are logically grouped, it is better to use a package. The code will be more organized. So in the package specification, we create or replace package. We have two functions. So let's create this. The package specification created. Then we create a package body. Package body is created. Here we have the square area and rectangle area. These two functions, their body, their implementation is defined here. And then in the initialization section, this is printed. Whenever a package is invoked, this initialization section will always get invoked. Now how to call this? This is the name of the package is area. So area dot square area. So we can call it this way. It's seen. Then we can call the rectangle area in this way, area dot rectangle area 40, and we can also call as an expression, and if you see the output, it's coming as 16. Then we can drop. We don't need those functions, so let's drop those functions. Okay. Now working with packages. Okay. Now working with packages, overloading subprograms in PL/SQL. This enables you to create two or more subprograms with the same name, requires that the subprogram's formal parameters differ in order, number, order, data type family, enables you to build flexible ways by invoking subprogram with different data, provides a way to extend functionality without loss of existing code, that is adding new parameters to the existing subprogram, provides a way to overload local subprograms, package subprograms, and type methods, but not standalone subprograms. So overloading is not possible for standalone subprograms, but for package subprograms, we can overload the subprograms. So it's basically the same name. Suppose we have a method A, and we can have another method also A, but there should be a difference in the parameter list. So one can accept say 2 parameters, the other accepts 3 parameters. So we can overload them. And when we call these subprograms, depending upon the parameters that we are passing, number of parameters, type, data type of the parameter, depending upon all these factors, Oracle server decides which subprogram to invoke. Restrictions: you cannot overload subprograms if two subprograms, if their formal parameters differ only in data type and the different data types are in the same family. So I said the subprograms parameters, if they differ in data type, then also you can overload them, but the difference must not be within the same family. Say number, one parameter is number, the other parameter is decimal, and you will try to overload them, that is not possible. Two subprograms, if their formal parameters differ only in subtype, and the different subtype are based on the same family. So varchar and string, they are subtypes of varchar 2, so you cannot overload them. Two functions differ only in return type, even the types are in different families. So based on the return type, you cannot overload. You have to overload based on the parameters that are functions. The preceding restrictions apply if the names of the parameters are also the same. If you use different names for the parameters, you can invoke the subprogram using positional, using name notation for parameters. So using name notation, you can overload subprograms. You can invoke subprograms, overloaded subprograms if the parameter names are different. The compiler tries to find declaration that matches the call. It searches first the current scope, then necessary, if necessary, in successive inclusive scope. The compiler stops searching if it finds one or more subprogram declaration between the name matches the name of the call subprogram. For similarly named subprograms, the same level of source, the compiler needs exact match in number, order, data type between the actual and the formal parameters. Here you see an example of function procedure overloading. At department, the first one accepts 3 parameters, the second one accepts 2 parameters. So we can overload them. So in the body also, it will be the same as the specification. Only thing is, we will have the logic, implementation logic. Using forward declarations, illegal procedure reference. So this here it's a illegal procedure reference. Replace block structure language session must declare identifiers before referencing. Example of reference is referencing problem. So we are creating a package body forward package, then we are calling it, and after that we are defining the procedure. That is illegal reference. So to avoid illegal reference, we do a forward declaration. So we declare the procedure beforehand. We can then implementation we can define later, but the declaration we have to do before calling the subprogram. Persistent state of packages. The collection of package variables and the values define the package state. The package state is initialized when the package is first loaded. Persistent by default for the life of the session, stored in the user global area, unique to each session, subject to change when package subprograms are or public variables are modified. Non-persistent for session but persistent for the life of the subprogram call when using pragma serially reusable in the package specification. Okay, let's look at some of the examples that we learned. This is chapter 30. So drop table customer, if you try to drop the table, it says table does not exist. Create table customer, let's create the table. So this is an example of package function procedure overloading. So we have two procedure add underscore cast. The first one takes 3 parameters, the second one takes 2 parameters. Then we create the package body. Here we create the package body created. The package body name is overload proc, overload underscore proc. So overload underscore proc. Add cust, these are 3 parameters, so it is calling the first add cust procedure. So this code will run, this code will run. So if we do this, we run this. Execute will not work, we have to write it in this format, begin. Execute works in SQL plus, okay. Now if we select start from customer, you will see birthday also populated. Now let's run this one. Two and 4, if we run this, now it's select from the customer. So birthday is empty because it's called the second procedure. It's called the second procedure, so birthday is empty because we are not populating the birthday in the second procedure. So here another example of overloading is add cust. This first procedure takes 3 parameters, but the second and third takes 2 parameters each. But if you see the order of the parameters are different. In the second procedure, PID is a number and PName is a varchar 2. In the third procedure, the first parameter is PName and the second procedure is PID. So we can, depending upon how we are calling the subprogram, it can figure out which subprogram to call. So that is about package, that's about overloading packages. Next we will move on to using Oracle supplied packages in application development. Oracle loading packages. Next we will move on to using Oracle supplied packages in application development. Oracle supplied packages are provided with the Oracle server, extend the functionality of the database, enable access to certain SQL features that are normally restricted for PL SQL. For example, DBMS underscore output package was originally designed to debug PL SQL programs. Some examples are like DBMS output, UTL file, UTL mail, DBMS alert, DBMS log, DBMS session, DBMS underscore scheduler. This is an abbreviated list of some Oracle supplied packages. DBMS output package, the DBMS underscore output package enables you to send messages from the subprograms and triggers. Put and put line place text in the buffer. Get line and get lines read the buffer. Messages are not sent until sending subprogram or trigger completes. Use set server output on to display messages in SQL Developer and SQL Plus. UTL file package extends PL SQL programs to read and write operating system text files. Provides a restricted version of operating system stream file IO for text file. Can access file in operating system directories defined in create directories statement. So file processing using UTL file, open for reading, fopen. When you say fopen, it will open the file for reading. get lines from the text file, more to read. If yes, it will go back to get lines from text file. When the more to read is no, it will close the text file. And writing to a file is open for write or append. Put lines in the text file, more to write. No, it will close the text file. Yes, it will go back to keep writing. It will go back and put lines in the text file. So these are the exceptions that are available in UTL file: invalid path, invalid mode, invalid file handle, invalid operation, read error, write error, and internal error. These are some of the exceptions that are raised in UTL file. fopen and isopen function. fopen takes the parameter p location, p file name, and p open mode. Open mode is read or write. Isopen determines whether file handle refers to an open file. It returns a boolean. What is UTL mail? UTL mail is a utility for managing emails. Requires setting up SMTP out server database initialization parameters. Procedure provides the following procedures: send attach raw, send attach raw, attach varchar2 or messages and text. How UTL mail will work? The DBA install UTL mail package, Oracle Home RDBMS admin util mail.sql and Oracle Home admin RDBMS admin prbt mail.plb. Define the SMTP out server in the init.ora file. Grant execute on UTL mail to user or public. The DBA add record in ACL access control list using package dbms underscore network underscore ACL underscore admin. Now the user can use UTL file. UTL mail, sorry. UTL mail summary of subprogram. There is send procedure, send attach raw procedure, send attach varchar2 procedure. So these are some of the procedures of UTL mail subprograms. This is a send procedure. The packages an email into appropriate format, locates the SMTP information and delivers the message to the SMTP server for forwarding to the recipient. This is the signature for send attach raw procedure. The procedure is the send procedure overloaded for raw attachment. Overloaded for raw attachment. Then this is a send procedure overloaded for varchar2 attach. Okay, let's stop here for 5 minutes. Then we'll continue on the next chapter. Thank you. Back. So let's continue with the next chapter, which is using dynamic SQL. Execution flow of a SQL. As all SQL statements goes through some or all of the following stages: parse, bind, fetch, and execute. Execute and fetch. Parse. This checks the statement syntax, validating the statement, ensure all referencing objects are correct, the privileges exist. This is the function of parse. Bind checks the bind variable if the statement contains any bind variables. Execute is execute the statement, non-query statement, and fetch is query statements, retrieve the row. What is dynamic SQL? Dynamic SQL is the SQL statement created dynamically at runtime, not at compile time. Suppose you want to create a procedure which will take table name p underscore table and it will delete from that table. If you want to write it the way it is shown, it will not work. It will give an error, compilation error. The solution is to use dynamic SQL execute immediate or native dynamic SQL DBMS underscore SQL. What is dynamic SQL? Use dynamic SQL to create SQL statement whose structure may change during runtime. Dynamic SQL is constructed and stored as a character string, string variable or string expression within the application. If the SQL statement with varying column data or different conditions with or without placeholders. Enable DDL, DCL session control statements to be written and executed from PL SQL. Is executed with native dynamic SQL statement or DBMS SQL package. The full text of dynamic SQL statement might be unknown until runtime. Therefore, syntax is checked at runtime rather than compile time. You can use dynamic SQL statements to make your PL/SQL program more general and flexible. When do you need dynamic SQL? In PL/SQL, you need dynamic SQL in order to execute the following. SQL whose text is unknown at compile time, such as a select statement that includes an identifier that is unknown at compile time, such as table name. Where clause in which column name is unknown at compile time. So all these cases we can use dynamic SQL. Native dynamic SQL provides native support for dynamic SQL directly in the PL/SQL language, provides the ability to execute a SQL statement whose structure is unknown until execution time. If the dynamic SQL statement is a select statement that returns multiple rows, NDS gives you the following choice. Use execute immediate statement with bulk collect into clause. Use open for fetch close statements. In Oracle 11G, NDS supports statement larger than 32K by accepting CLOB argument. So you can use a CLOB as a statement string. Use execute immediate statement for NDS or PL/SQL anonymous block. Execute dynamic string into defined variable using bind arguments. Into is used for single row queries and specific variables and record in which column values are retrieved. Using this to hold all byte arguments, the default parameter mode is in. An example, the earlier delete any table procedure is now written in this way: execute immediate delete from. Then we concatenate with the p table name, the parameter that we are passing. Then we are taking SQL first and row count, and then we are printing so many records are deleted from this table. This is how we execute the procedure. So this is how we write dynamic SQL using example. P value is a number, add rows. P value is a number, P table name is another parameter, P value number is another parameter. So we are executing insert into P table name value :1 using P value. Give me 1 second, please. Hello. So this is an example of using dynamic string using clause. This is an example of dynamic single row query. Execute immediate V query into mprec. Mprec is a employees person row type record type. So into that record type we are collecting the results of executing V query, and also we are using PID. This is how we invoke the procedure. So an example of multi-row query. So here we define a ref cursor, select employee ID first name from employees. This is our SQL. Then we have couple of variables. So we open the cursor, push the SQL using P department ID. P department ID is a parameter. Then we fetch it in a loop. We fetch into VM number, V first name, and we exit when the cursor not found, person not found. So every time we are retrieving the employee number and the first name into VM number, V first name variable, and then we are printing the message. We are printing the VM number and V first name. That's all we are doing. This is an example of multi-row query. In anonymous block, we can declare V code, our code is in the declare section. Then in the begin, in the executable section, we can execute immediate V. Using DBMS SQL package, DBMS SQL package is used to write dynamic SQL instead procedure and parse DDL statements. You must use DBMS SQL package to execute dynamic SQL that has unknown number of inputs or output variables, also known as method 4. In most cases, LDS is easier to use and performs better than DBMS SQL, except when dealing with method 4. For example, you must use DBMS SQL in the following situation. You do not know the selects list at the compile time. You do not know how many columns a select statement will return, what their data type will be. In these cases only we use DBMS SQL. Otherwise, in all other cases we use NDS, that is executable. There are a couple of steps in DBMS SQL. One is open cursor, second one is parse, bind variable, execute, fetch rows, close cursor. The parse procedure, the lang flag parameter of the parse procedure, how Oracle handles the SQL statement. That is behavior associated with specific Oracle database version. Using native or one for the specification, the normal behavior associated with the database which the program is connected. If the language parameter is set to V6 or 0, that specifies version 6 behavior. If the language parameter is V7 or 2, specify version 7 behavior. But we normally use DBMS SQL.native. So here is an example of using execute immediate and the same code using DBMS SQL. So in DBMS SQL, we first open the cursor, then we parse the cursor, then we execute. So these are the steps in DBMS SQL. Okay. The next chapter is the design consideration for PL/SQL code. The next chapter is the design consideration for PL/SQL code. Some of the design consideration is standardizing constant and exceptions. Constant and exceptions are typically implemented using a bodiless package, that is a specification, package specification. Standardizing helps to develop programs that are consistent, promote a higher degree of code review, easy code maintenance, implement company standard across entire application. Start with standardization of exception names and constant definitions. Here's some example of standardizing exceptions. Standardizing exception handling. Consider writing a subprogram for common exception handling to display errors based on SQL code and SQL ERRM for exceptions. Track runtime errors easily by using the parameters in your code to identify the procedure with which the error occurs, the location of the error, raise application error using stack trace capabilities with third argument set to true. Standardization constant for programs that use local variables whose value should not change. So they are constants. So convert the variable to constant to reduce maintenance and debugging. Create one central package specification and place all constant into it. In it. Here are some examples. So we are creating a global measurement package specification and defining some constant in it. A local subprogram is a procedural function defined at the end of the declarative section. So we have a procedure, and in the end of the declarative section, that is and begin, we write a function. So this is a local subprogram. This is only accessible within this procedure. Why use local subprograms? A reduction of repetitive code, code readability, and easy maintenance. Definer right and invokers right. Actually, when a subprogram executes, it executes either in definers right or invokers right. What is the difference between them? Definers right used prior to A-type, invokers right introduced in A-type. Program executes with the privilege of the creating user. Program executes with the privilege of the calling user. So the definer right, the program is executed with the privilege of the owner, and in invokers right, it is the privilege of the user who is executing the program. In definer right, the user does not require privilege on underlying object that the procedure access. User requires privilege only to execute a procedure. But in invokers right, user requires privileges on the underlying objects that the procedure accesses. Specifying invoker right, setting auth ID to current user. By default, auth ID is definer, which is the definer right. By default, all subprograms execute in definer right. If you want to execute in invoker right, you have to specify in this way auth ID current user. The next is autonomous transaction. They are independent transactions started from another main transaction, as specified with pragma autonomous transaction. So what is the significance of an autonomous transaction? The significance is that it is an independent transaction. Within a main transaction, you are calling this transaction so here we create or replace the procedure child block. Child block inserts into table T and then commits. But this commit is autonomous. So in the left hand side, you see we have another procedure parent block within which we are calling the child block. So child block with insert into table T and commit, but the parent block has rolled back. But still the commit that happens in the child block will persist. So we will find the record in table T. And we define the autonomous transaction with autonomous underscore transaction pragma. Features of autonomous transaction is they are independent of main transaction, suspend the calling transaction until autonomous transaction are completed, are not nested transactions, do not roll back if main transaction roll back. Enable the change to become visible to other transactions upon commit. Are started and ended by individual subprograms and not by nested or anonymous PLSQL blocks. So basically, suppose you have a logical subprogram where you define your business logic, but for debugging, you want to insert into a table so you can find out what is happening while your program is running. Now, in a normal circumstance, if you are writing a normal insert into table statement without doing a commit, because you cannot commit, because otherwise your main transaction will get committed. So you cannot commit in a normal way. But if you define an autonomous transaction, autonomous transaction procedure to write the debug statement and commit, then it will commit that debug line into the table. So you can watch the table, you can query the table and find out what is going on in your main transaction flow. So that is a common use of autonomous transaction. Using the NOCOPY hint allows the PLSQL compiler to pass out and in-out parameters by reference rather than by value. Enhances performance by reducing the overhead when passing parameters. So for that we have to use the NOCOPY hint. When we use the NOCOPY hint, it is passed as the parameters are passed by reference, and only out and in-out parameters can be passed as NOCOPY. In parameters are always passed by reference. So in parameters you cannot pass by NOCOPY. Inner parameters can be passed by value default, passed by reference using NOCOPY. Passed by value is an example. Declare x number 10, test x, test n equal to colon equal to 15. The code for changing the n value done on the temp buffer. So copy in, copy out. And when you say by no copy, then no copy means we are not passing the parameter by value, we are referencing the parameter. So we set it to 15, then this the left hand side procedure will also get 15 value. When does the PSQL compiler ignore the no copy hint? The no copy hint has no effect if the actual parameter is element of an index by table is constrained by, for example, by scalar or not null. The formal parameter are records where one or both records are declared using %root type or %type. Requires an implicit data type conversion. So in these cases, the subprogram is involved in an external or remote procedure call. In all these cases, no copy hint will be ignored. Function result cache. Function result cache is basically when you create a function, you can include the function result clause. We can include the result cache clause in the function declaration, function definition. And an example, we creating a embedded function, which where we say result cache relies on employees. It means that this function will cache the result in the SGA, in the shared pool. So next time when you call the function, it will not execute the select statement within the function, but it will take the value from the cache and return to the calling program. So that way performance is greatly improved. And this relies on clause tells us that if there is any changes in the employees table, then the cache will be invalidated. So if you are changing the employees table, then the cache will be invalidated, and you will have to query the database again to get the cache. So that is about reserve cache. Bulk binding, PL/SQL and SQL, they are two different engines. So from PL/SQL, when we call SQL, there is a context switch, and then from SQL, when the result returns to PL/SQL, there is another context switch. So to avoid that multiple context switch, we can use bulk binding. Syntax is, for bulk binding, we do a bulk collect into a collection object, and then using for all statement to do the insert. So for all statement to do the insert operation at once. So these are all performance improvement techniques. One is the result cache, the other is a bulk collect and for all. We'll next move on to the creating triggers. Okay, I'm back. So now let's continue with triggers, creating triggers. What are triggers? A trigger is a PSQL block that is stored in the database and fired or executed in response to a specific event. So for a specific event, the trigger will execute. The Oracle database automatically executes a trigger when specified condition occurs. So suppose you are inserting into department some values in the departments table, and we have written a before insert trigger and after insert trigger. So before inserting into the departments table, the before insert trigger will fire, and after the insertion, the after insert trigger will fire. Defining triggers are triggers can be defined on table, view, schema, or database. So in all these cases, we can define triggers. The trigger event type is, we can write triggers that fire whenever one of the following operation occurs in the database. The DML statement, delete, insert, update, a data definition state language statement, create, alter, drop, a database operation such as server error, log on, log off, startup, or shutdown. So in all these cases, you can write triggers. Application and database triggers fires when DML or DDL system event occurs on a schema or a database. Application trigger occurs when you, in your application, like in your forms application, when you press the login button, then when button press trigger will fire. But that is outside the scope of this course because that is not part of PHSQL, that is part of Oracle form or the application that you are using. Business application scenarios for implementing triggers. You can use triggers for security, auditing, data integrity, Gaussian integrity, table replication, computing derived data automatically, event logging. For all these cases, you can use triggers. That one available trigger types are simple DML triggers. They are before, after, and instead of. Compound triggers and non-DML triggers like DDL event triggers, database event triggers. Trigger event types and bodies. A trigger event type determines which DML statement causes the trigger to execute. The possible events are insert, update, delete. The trigger body determines what action to be performed and is a PLSQL block or a call to a procedure. DML triggers, there are two types, statement level and row level. Statement level fires for each DML operation and row level fires for each row. So statement level triggers is default when creating a trigger, fires once for the triggering event, fire once even if no rows are affected. So that is statement level. Row level triggers is for each row clause we use each for each row clause to define a row level trigger. Fires once for each row affected by the triggering event, does not fire if the triggering event does not affect any row. Statement level trigger, common cases, when you want to check security before DML operation, date, time, when you want to check user profile before DML operation. So here no need to fire the trigger for each row, the trigger will fire only once. Update AMP says salary plus 10, where empid is equal to 1. One row, update employee equal to salary plus 10, all rows will be updated, but the trigger will fire only once. When you need the old and the new values from the DML, here you should use the row level trigger. So update employee says salary is equal to sal plus 10, you need the old sal and the new sal, then you need to write a row level trigger. So statement level trigger example. So here is an example. If it's not between 8 and 16, then if the time is not between 8 and 16, then we say DML operation not allowed now. In the trigger, we can also use like if inserting, if deleting, if updating. And here is an example: before insert, update or delete. If inserting, you have a certain logic. If deleting, you have a certain logic. If updating, you have a certain logic. And the old and new cases, in case of insert 1 and IT, you are inserting the values. In case of insert, old value is null, new value is the inserted value. In the case of update, the old value is a value before the update and new value is a value after the update. In case of delete, the old value is value before the delete and new value is null. For each row level triggers, this is an example for each row. If salary is less than 500, we are throwing a message, minimum salary is 500. This is before insert or update of salary. Row level triggers new and old and new qualifiers. When a row level trigger fires, the PHP runtime engine creates and populates two data constructs, old and new. New and old have the same structure as record. And here this table I have already explained. These are the values in the new and old construct. Trigger firing sequence is before statement level trigger will fire, before row trigger will fire, after row trigger will fire, and after statement trigger will fire. Here you can alter the trigger, you can disable the trigger, you can compile the trigger, recompile a trigger, you can remove a trigger from the database by drop trigger option. Instead of triggers is created on views. You cannot update a view, but instead of that you want to do some insert into some other table, so you can use instead of trigger on a view to do some other insert, so to do some other operation like inserting into some other table or inserting into a log table or whatever you need to do. You can write a instead of trigger on a view. Okay, next is creating compound DDL and event triggers. See, there is a two trigger T1 which is before insert of the EMP and T2 which is before insert of the EMP. Now there is no guarantee which trigger will fire because they are at the same level. So you can use a keyword follows T1. T2 will follow T1. So T1 will fire first and then T2. What is a compound trigger? Compound trigger is we have a before statement level, before each row trigger, after each row trigger, and after statement level trigger. We can compound all these triggers into a single trigger, and that is known as a compound trigger. So what is a compound trigger? A single trigger on a table that allows you to specify action on each of the following 4 timing points. Before the firing statement, before each row that the firing statement affects, after each row that the firing statement affects, and after the firing statement. Starting from 11G, you can define a compound trigger. Compound trigger structure is here. This is the syntax for compound trigger. Yeah, create or replace trigger test for insert or update or delete on text underscore EMP compound trigger. Before statement is before each row, after each row statement, and after statement. End. So this is a compound trigger example. compound trigger restriction. A compound trigger must be a DML trigger and defined on either a table or a view. The compound trigger, the body of a compound trigger must be a compound trigger block written in PL SQL. A compound trigger body cannot have an initialization block, therefore it cannot have an exception section. A compound trigger body, then exception of that occurs in one section must be handled in that section. It cannot transfer control to another section. Old and new cannot appear in declaration before statement, after statement section. Only the before each section can change the value of :new. The firing order compound trigger is not guaranteed unless you use the follows clause. This is an example of compound trigger structure on views, where we write instead of each row. Triggers and mutating table. Remember a trigger, if you are writing a trigger on a table and you are accessing the table data, then you get a mutating, in the same trigger, you get a mutating error. Comparing trigger to a stored procedure. Triggers are defined in create trigger, stored procedure are defined with create procedure. Data dictionary contains source code in user triggers. Data dictionary contains source code in user source. Invoked by DML, explicitly invoked. Triggers are implicitly invoked by DML. Procedures are explicitly invoked. Commit, save point, rollback are not allowed in trigger. Commit, save point, rollback are allowed in a procedure. So defining trigger. Creating a trigger on DDL statement. Sample DDL events create, alter, drop. So we can write a trigger on each of these. There is an example before create on schema. So you are checking if it is not between 8 and 16, we are saying create table not allowed now. If user HR try to create a trigger at 16, 18 in 6 o'clock in the evening, for example, it gives an error. Defining triggers. Database event triggers are like log on, log off. Also create, alter, drop. Here is an example of before create on database. So you cannot create any object unless it is between 8 and 16. Here is an example of after logon trigger. We are inserting into a log table. Benefits of database event triggers: improve data security, provide enhanced and complex security checks, provide enhanced and complex auditing, improve data integrity, enforce dynamic data integrity constraints, enforce complex referential integrity constraints, ensure that related operations are performed together implicitly. System privilege to manage triggers. The following system privileges are required to manage triggers: create, alter, drop any trigger privilege that enables you to create a trigger in any schema. The administer database object trigger privilege enables you to create triggers on a database. Execute privilege if the trigger refers to object that not in your schema. Guidelines for designing triggers. You can design triggers to perform related action, centralized global operation. You must not design triggers where function is already built into Oracle Server that duplicates other triggers. You can create stored procedures and invoke them in triggers if the PLSQL code is very lengthy. Excessive use of triggers can result in complex interdependencies which may be difficult to maintain in large applications. So that's about triggers. So today we covered packages, working with packages, using Oracle support packages, using dynamic SQL, design consideration in PLSQL code, creating triggers, compound triggers. So all this we have covered. So we are left with 3 chapters which we will cover tomorrow. So bye for today. I hope to see you tomorrow. Thank you. Hi, good morning. We have till now covered till chapter 18. So all the ones that are highlighted in yellow have been covered. So we are left with remaining three chapters using PL/SQL compiler, managing PL/SQL code, and managing dependencies. Okay, so let's start with chapter 19. Using PL/SQL compiler. Prior to Oracle Database 10G, the PL/SQL compiler translated your source text to system code without applying many changes to improve performance. But after 10G, starting 10G, PL/SQL uses an optimizer that can rearrange the code for better performance. Using PL/SQL compiler, PL/SQL uses a new optimizing compiler that can rearrange code for better performance. PL/SQL performance is improved across the board. Most improvements are automatic. The default optimization level improves performance for a broad range of PL/SQL operations. The default is 2. PL/SQL optimizer level, that's the initialization parameter, and that is by default 2. So what are the changes in PL/SQL compiler? Elimination of compiler generated temporary operands, computation of some operations during compilation, the use of some expression values, simplification or elimination of some branches and dead code elimination, avoidance of library calls by direct execution in the PL/SQL virtual machine of some operations, all cursors correctly finalized upon exit from a cursor loop or a declared block, elimination of computations whose only effect is as a side effect to raise an exception. So the initialization parameters for PL/SQL compiler are PL/SQL code type, PL/SQL optimized level, PL/SQL CC flag, PL/SQL wordings. You can select the values from $v parameter where name is equal to, you can give the parameter name, like as for example PL/SQL code type. So the DB has to log in as sysdb and can select on $v parameter to the HR schema or to the user schema. New compiler settings since Oracle 10G. PL/SQL code type specifies the compilation mode of PL/SQL library unit. PL/SQL optimized level specifies the optimization level to be used to compile PL/SQL library unit. PL/SQL warning enables or disables the reporting of warning message by PL/SQL compiler. PL/SQL CC flag controls conditional compilation of each PL/SQL library unit separate independently. In general, for the fastest performance, use the following settings. PL/SQL code type is equal to native and PL/SQL optimization level is equal to 2. This is for fastest performance. Using initialization parameter for PL/SQL compilation, PL/SQL code type specifies the compilation mode of PL/SQL library. It can be interpreted or native. Interpreted PL/SQL library units will be compiled into PL/SQL bytecode format. Such modules are executed by PL/SQL interpreter engine. Native PL/SQL library units, with the possible exception of top-level anonymous PL/SQL block, will be compiled in native or machine language. Such modules will be executed natively without incurring any interpreter overhead. When the value of parameter is changed, it has no effect on PL/SQL libraries that has already been compiled. The value of this parameter is stored persistently with each library unit. If a PL/SQL unit is compiled native, all subsequent automatic recompilation of that library unit will use native compilation. Using initialization parameters for PL/SQL compilation, PL/SQL code type that is native or interpreted. So this is how I change the PL/SQL code type. Alter session set PL/SQL code type is equal to native or interpreted. You can display from user PL/SQL object settings where name is equal to P1. So you can see what is the PL/SQL code type in user underscore PL/SQL underscore object underscore settings. For each object, you will find the PL/SQL code type. The PL/SQL code type parameter in Oracle 10G replace the following obsolete parameter: PL/SQL native C compiler, PL/SQL native make file name, PL/SQL native C compiler, PL/SQL native make utility, PL/SQL native linker. All these have been made obsolete, and now PL/SQL code type is the parameter that we need to set. PL/SQL optimization level specifies the optimization level to be used to compile PL/SQL library units. If it is 0, it means maintains the evaluation order, and hence the pattern of side effects, exceptions, and package initializations of Oracle 9i and earlier releases. Also removes the new semantic identity of binary integer and PLS integer, and restores the earlier rules for evaluation of integer expression. Although code will run somewhat faster than it did in Oracle 9i, use of level 0 will forfeit most of the performance gains of PL/SQL starting with Oracle 10G. So we should not use 0. One applies a wide range of optimizations to PL/SQL program, including the elimination of unnecessary computation and exceptions, but generally does not move source code out of its original source order. 2 applies a wide range of modern optimization techniques beyond those of level 1, including changes which may move source code relatively far from its original location. And 3, this value is new in Oracle Database 10G, 11G. It applies a wide range of comparison techniques. This enables procedural inlining, which is an optimization process that replaces procedural calls with a copy of the body of the procedure to be called. So optimization level specifies the optimization level used to compile PL/SQL library unit. Generally, setting this parameter 2 pays off in terms of better execution performance. If, however, compiler runs so slowly on a particular source module, or if the optimizer does not make sense for some reason, then setting this parameter to 1 results in almost as good a compilation with less use of compile time resources. The value of parameter is stored persistently with the library unit. So basically the default value we should choose is 2. Overview of PL/SQL compiled warnings. So when we compile before 10G, if you compile, it will either success or fail. After 10G, if you compile, it will success, warning, and failure. There's 3 possibilities. Earlier it was success and failure, now we have a warning also. Starting 10G, PL/SQL compiler has enhanced to produce warnings for subprograms. So PL/SQL program, an example of a warning is parameter IO underscore TBL may benefit from use of NOCOPY compiler key. This is not an error, this is a warning. So you may honor the warning or you can ignore that. Benefits of compiler warning makes the program more robust and avoid problems at runtime, identify potential performance problems, identify factors that produce undefined results. Anonymous do not need all results. There are different types of warning. One is severe, one is performance, one is informal, one is all. Severe means messages for conditions that may cause unexpected behavior or wrong results, such as aliasing problems with parameters. Performance messages for conditions that may cause performance problems, such as passing a varchar2 value to a number column in an insert statement. Informational messages for conditions that do not have an effect on performance or correctness, but you may want to change to make the code more maintainable, such as unreachable code that can never be executed. Settings the warning message level. You can set warning levels using the following methods: declaratively, using PL/SQL underscore warnings initialization parameters, programmatically using DBMS underscore warning package. So here is an example: alter session or system PL/SQL warnings is equal to the value clause, or alter session PL/SQL warnings disable all, alter session PL/SQL warning enable informational, enable severe. So this is how you enable the warning labels. Some examples are here. You can also query the $v parameter to see what is the PL/SQL warnings currently. To see the PL/SQL warning, viewing compiler warning using SQL Developer, SQL Plus or Data Dictionary view, you can view errors warning in SQL Developer or show errors in SQL Plus. Use user all DB errors you can also use to see the warnings. Guidelines for using PL/SQL warning. The setting for the PL/SQL warning parameters are stored along with each compiled subprogram. If you recompile the subprogram using one of the following statements, the current setting for that session are used: create or replace or alter compile. If you recompile the program using alter compile statement with reuse settings clause, the original settings stored with the program is used. So there are two ways to set the warning message level. One is PL/SQL warnings initialization parameter, another is DBMS warning package. DBMS warning package, the subprograms are mentioned here. Add warning setting category, add warning setting num is the procedure. Then query warnings, get warning setting category, get warning setting number, get warning setting string. These are all functions. Replace warning set, warning setting string, categories name, get category. Here you can see an example of add warning setting cat example and warning setting num example. Example continues. You can see the select statements using get category and set warning setting string. the new PLS 06009 warning message. The new PLW warning is available in Oracle Database 11G. The warning includes the others handler of your PSQL subroutine can exist without executing some form of raise or a call to a standard procedure raise application. In a good programming practice suggests that the others handler must always pass an exception upward. So that's it about PL/SQL compiler. Next chapter is managing PL/SQL code. Hello, I'm back. So let's continue with this chapter, managing PL/SQL code. Describe and use conditional compilation, hide PL/SQL source code using dynamic obfuscation and wrap utility. What is conditional compiling? Suppose you are creating a function with result cache hint, but the function, this option of result cache is started in 11G. So customer use 10G, customer use 11G. So how can I move it with one source code? So in compilation, what is compilation? Conditional compilation enables you to customize the functionality in a PL/SQL application without removing any source code. Utilize the latest functionality of the latest database release and or disable the new feature to run the application against an older release of the database. Active debugging tracing functionality in the development environment hides that functionality in the application while it runs in production site. The constructor if, $then, $else, $else if, $end, $error. So these are the output. These are the reserve processors control tokens. So using some control token, we can do a conditional compiling. Benefits of conditional compiling: support for multiple versions of the same program in one source code, easy maintenance debugging of code, easy migration of code to a different release of database. How does conditional compilation work? Selective directory use of $if token, inquiry directive use of $token, error directive use of $error token, dbms underscore preprocessor package, dbms underscore db version package. So example of dbms underscore db version package. Select text from all source where lower name is equal to dbms underscore db version package order by line. So you get example. So this you get this example. So we are printing dbms output dot put line dbms db version dot db version dot release. So these are the db version is available. So selection directive is Boolean expression, then else if, then else and end. Here is an example: get salary. If dbms db version dot version greater than 11G, then result cache end. So this is the directive. This is the conditional compilation. So if it is greater than 11G, if the database version is greater equal to 11G, starting 11G, it will be a result cache function. Then inquiry directive, predefined inquiry directive, PL/SQL CC flag, PL/SQL port type, PL/SQL debug, PL/SQL optimization, optimize level, PL/SQL warning, analyze length semantics, PL/SQL line, PL/SQL unit. These are user predefined inquiry directives. So an example is if $PSQL optimization not equal to 2, then we are populating the error. In intensive program must be compiled with maximum optimization. So we will get a compile time error. So here is an example. If you create a replace procedure G underscore test where we are saying if PLSQL compilation optimized level not equal to 2, then we are throwing an error. It should be compiled with PLSQL compilation level equal to 2. And when we try to compile the procedure in the compiler log, you see that error message is appearing and it won't let you compile. So what is obfuscation? Obfuscation or wrapping of PLSQL unit is a process of hiding the PLSQL source code. Suppose you want to deliver your code to the customer, but you don't want to reveal your source code. So you can wrap the source code. If you are wrapping your source code, then it prevents others from seeing your source code. Your source code is not visible through user source, all source, or DBA source data dictionary. SQL Plus can process wrap source files, export import utility, accept wrap files. So using DBMS underscore DDL dot wrap function, we can dynamically wrap the source code. So the example is DBMS DDL dot create wrapped, and then you give your code, and then you see in the right hand side right hand side bottom you see the wrapped code when you query the user source. There is also a wrapper utility which you can use the wrapper utility using the wrap command. This wrap command you will find in Oracle installation in the Oracle home bin directory, and this wrap command takes an in name which is an input file name and an out name which is output file name. The in name is the name of the source code and output file name is the wrapped source code. The default extension for input file is .sql. The default extension of output file is .plb. You must wrap only package body, not package specification. The wrap can detect syntactical error but cannot detect semantic errors. The output file should not be edited. You maintain the original source and the wrap again as required. To ensure the important parts of your source code are wrapped, view the wrap file in a text editor before distributing it. Comparison between DBMS DDL package and wrap utility. DBMS utility code obfuscation is yes in both the cases. Dynamic obfuscation is yes for DBMS DDL. Wrap utility is no. Obfuscate multiple programs at a time. DBMS DDL is no, but wrap utility is yes. So you can wrap multiple files through the wrap utility. So that is about wrapping. Then we move on to our last chapter, which is managing dependencies. Then we move on to our last chapter, which is managing dependencies. Managing dependencies Example is procedure A, which is based on procedure view B, and view B is based on table C. So they are dependent. Create or replace view B M copy. This is a dependent object as select star from M copy. This is a reference object. If the definition of object A references object B, then A is a dependent object, B is a referenced object. So VM copy is a view which is now valid, but if we drop the table M copy, the view becomes invalid. So if you drop the reference object, the dependent object becomes invalid. So this is the dependency. Overview of schema of the dependencies. Package body can be dependent or reference. Package body can be dependent only. Package specification can be both dependent or referenced. Sequence is referenced only. Subprogram both. Synonym both. Table both. Trigger both. User defined object both. User defined collection both. View both. If you alter the definition of a reference object, the dependent object may or may not work. As for example, create or replace view V department copy, select department name from department copy. Alter table department as size number, the change will not affect and V department copy will still be valid. This is from 11G. So your change does not affect the select query, so the view will remain valid. But if you say department copy drop column department name, then your select query is affected, so your view becomes invalid. Indirect local dependencies, example students table. Print all students from V1. So select start from V1 students, then we are printing. The procedure read from a table but not direct from a from the view. So from the view, a procedure function can directly or indirectly reference table, view, sequence, procedure, function, package procedures or functions. So instead of selecting from V1 view, then we have a view, V1 student, select start from students. So direct local dependencies, create or replace view, select start from students, V1 student, select start from student, V2 students, select student ID, student name from students. The two views are and the procedure reading directly the table students. Create or replace procedure print all students. For I in select star from students, then you are printing the ID and the name. This is directly selecting from the students. P2 students is also directly selecting from the students. So if you select star from all user dependencies where referenced name is equal to students, you will see the V1 students, V2 students, and print all students procedure. These are the dependent objects of students table. You can query the status of an object using user objects, DBA or all objects. Status can be valid or invalid. Procedure A is the direct dependent of B, B is the direct dependent of table C, procedure is an indirect dependent on table C. Direct dependencies are invalidated only by the changes to the reference object that affect them. Indirect dependencies can be invalidated by the changes to the reference object that do not affect them. So in this case, table C, if you make any change, procedure is not affected, but due to indirect dependency, it will become invalid. Guidelines for reducing indefinite to reduce invalidation of dependent object, add new items to the end of the package, reference each table through a view. Object revalidation. An object that is not valid when it is referenced must be validated before it can be used. Validation occurs automatically when an object is referenced. It does not require explicit user action. If an object is not valid, the status is either compiled with error or unauthorized or invalid. So remote dependencies. In case of remote dependencies, we will create a new pluggable database, new DB. Okay, that is a new pluggable database. We are creating a new user inside the pluggable database. We will create a database link. Recompilation of dependent object, local and remote. Verify successful explicit recompilation of dependent remote procedures and implicit recompilation of dependent local procedure by checking the status of procedure within the user object. Actually, this procedure is valid, which has a remote dependency on a procedure view or a table. The view and procedure are invalid, but this still the procedure is valid because it is a remote dependency, not a local dependency. Remote is governed by the mode chosen by the user. Timestamp checking, signature checking. Timestamp checking is each PLSQL program unit carries a timestamp that is set when it is created or recompiled. Whenever you alter a PLSQL program unit or a deliverable schema object, all its dependent units are marked invalid and must be recompiled before they can execute. The actual timestamp comparison occurs when the statement in the body of a local procedure calls a remote procedure. Signature checking for PLSQL, both timestamp and signature are recorded. The signature of PLSQL construct contains the information about the following: the name of the construct, the base type of the parameters of the construct, modes of the parameters, and number of parameters. The recorded timestamp in the calling program unit is compared with the current timestamp in the call remote program unit. If the timestamp match, all proceeds normal. If they do not match with the remote procedure, call layer performs a simple test to compare the signature to determine whether the call is safe or not. If the signature has not been changed in an incompatible manner, execution continues, otherwise an error is returned. Remote dependency mode parameter, remote dependency mode, and init or a parameter. Remote dependency mode, system level or session level. You can alter them. The values are timestamp and signature. The signature of a procedure is the name of the procedure, the data type of the parameters, and the mode of the parameters. The signature of remote procedure is saved in the local procedure. When executing a dependent procedure, signature of the reference remote procedure is compared. Recompiling PLSQL program units, you can do alter procedure, compile, alter function, compile, alter package, compile, alter package body, compile, alter trigger, compile. Unsuccessful recompilation, recompiling depending procedure function accessor when the reference object is dropped or renamed, when the data type of the reference object is changed, when the reference column is dropped, when the reference view is replaced with a view with a different column, a parameter list of a reference procedure is modified. In all this case, you will get an unsuccessful recompilation. Successful recompilation, recompiling depending on function is successful if the reference compiles as the new column. The literature has not changed. A private table is dropped, but a public table that has the same name and structure exists. The PSQL body of the reference procedure has been modified and recompiled successfully. Recompiling procedures minimize dependency failure by declaring recursive %row type, declaring variable with %type, querying the table with select star notation, including a list column in the insert statement. So these are very important tips to minimize dependency failure. To use a %row type, %type, and select star notation, and in the insert statement include the column list. That way you are making yourself less dependent on dependency failure. So that's all about the PL/SQL course that we have designed. So we have completed PL/SQL compilation, managing PL/SQL code, and managing dependencies. So all the chapters are now complete. Thank you and bye.